Welcome to this sanctuary of silence and starlight. Before we begin our journey into the cosmos, let us take a moment to anchor ourselves right here in the safety of this present moment. There is nowhere else you need to be, no task that demands your attention, and no worry that cannot wait until the sun rises again. For now, there is only the gentle rhythm of your own breathing and the soft, inviting weight of your body sinking deeper into the surface beneath you. Feel the tension unravelling from your shoulders, melting away like mist under the morning sun. Allow your eyelids to become heavy, drifting closed with a sense of profound relief, shutting out the world of forms and colours to open the inner eye of the imagination. Picture, if you will, the walls of your room slowly dissolving. They do not crumble, but rather fade away like smoke, revealing a vast, open expanse above you. You are safe, warm, and cradled by the night, lying comfortably under a canopy of pure velvet obsidian. The air around you is cool and crisp, carrying the scent of night-blooming jasmine and the earthy freshness of dew-kissed grass. But where you lie, you are wrapped in a cocoon of perfect warmth. High above, the sky is not merely dark, it is a deep, infinite canvas, dusted with the diamond dust of 1 trillion distant worlds. It is a spectacle of silence, a grand theatre where the actors are colossal spheres of burning light, performing a slow, eternal dance that has captivated every eye that has ever looked upward. As you gaze into this infinite abyss, let a sense of smallness wash over you. Not a smallness that feels insignificant, but a comforting smallness, the feeling of being a cherished part of a much larger, magnificent whole. You're made of the same stardust that glitters above. You're a child of this universe, resting in its cradle. Breathe in the stillness of the galaxy. Breathe out the noise of the day. With every exhalation, you drift further from the shore of wakefulness, pushing off gently in a small boat, floating out onto a calm, dark ocean of sleep, guided only by the glimmering lights above. Let us turn our attention to these lights, these silent guardians of the night, and let their stories lull you into the deepest, most restorative slumber. The journey begins not in the far reaches of the deep dark, but with the most familiar light of all, the one that paints our days with colour and warmth. Imagine for a moment the sensation of a gentle summer morning. You're not looking directly at the source, but you feel it, the golden star we call our sun. It is the closest star to us, a mere hop across the cosmic pond, yet it is the architect of all life we know. Visualize its light touching your skin, a physical weight of warmth that penetrates the muscles and bones, soothing aches and bringing a sense of vitality. This star is a colossal sphere, a churning ball of glowing plasma that holds our entire world in its gravitational embrace. It is a mother guarding her children, keeping the cold of the void at bay. Though it appears to us as a blinding yellow-white disk, if you were to float closer, shielded and safe, you would see it as a dynamic, living ocean of fire. Its surface is a texture of granules, like a field of golden wheat blowing in a slow-motion wind, constantly shifting and flowing. This star, our soul, is the anchor of our existence, the steady heartbeat of the solar system. It is a middle-aged star, steady and reliable, burning with a consistency that has allowed life to flourish for eons. Think of the comfort in that reliability, the promise that no matter how dark the night becomes, this great, warm star will always rise again to greet you. It is the first fact of the cosmos, that we are warmed by a star, that we live within the outer atmosphere of a star, and that its golden glow is the very definition of our days. And what is this golden giant made of? As we drift deeper into the nature of these celestial beacons, we find a simplicity that is strikingly beautiful. Imagine floating into the very core of a star, moving through the layers of heat and light until you reach the centre. Here, in the heart of the furnace, the universe is playing its favourite game, the merging of elements. Most stars, including our own, are woven almost entirely from the two lightest, most simple elements in existence, hydrogen and helium. It is a poetic thought, is it not? That the most majestic, heavy and powerful objects in the sky are built from the lightest, most ethereal breaths of the universe. Visualizing this, you might see a vast glowing fog of hydrogen atoms dancing and swirling in the crushing embrace of gravity. They are the fuel, the primal matter from the dawn of time. Under the immense pressure of the star's core, these atoms are pressed together, closer, closer, until they can no longer remain apart. They fuse, they merge. In this embrace, they transform into helium, and in that moment of transformation, a spark of pure energy is released. This is the secret engine of the stars, a continuous billions of year-long process of transmutation. It is alchemy on a cosmic scale. Every beam of light you see, every distinct twinkle in the night sky, is the result of this silent subatomic union happening trillions of times a second. It is a clean, pure burn, a fire that feeds on itself to create the light that travels across the universe to kiss your eyes. That light, born in the deep, crushing heart of a star, must then travel to reach us, and this journey introduces us to the concept of the sky as a time machine. When you look up at the tapestry of the night, you're not seeing the universe as it is right now. You're seeing it as it was. Light, though the fastest traveller in existence, still requires time to cross the vast, lonely boulevards of space. Imagine a single photon, a tiny packet of light, breaking free from the surface of a distant star. It begins a voyage across the emptiness, sailing through the vacuum for years, centuries, perhaps even millennia. It passes silent nebulas and wanders through the dark gaps between worlds, carrying with it the image of its home. Consider the star Sirius, the brightest jewel in our night sky. When you gaze upon its bluish-white brilliance, you're seeing light that left its surface over 8 years ago. If you look deeper, to the stars that form the belt of Orion, you're looking back centuries, seeing light that began its journey before you were born, before your great-grandparents were born. And if you could see the Andromeda galaxy with your naked eye, you would be looking back millions of years. This means the night sky is a living museum, a history book written in light. You're communing with the ghosts of the past. Some of the stars you see twinkling so merrily may have already burned out and died, but their final message of light is still travelling toward us, a farewell letter crossing the ocean of time. It brings a sense of profound peace to know that nothing in the universe is ever truly lost. Its image persists, echoing through the void long after the source has changed. As your mind drifts on these waves of time, let your imagination expand to encompass the sheer scale of the stellar population. Try to visualize a beautiful, pristine beach. The sand is white and soft, warm under your feet. You reach down and scoop up a handful of this sand, feeling the thousands of tiny, rough grains slipping through your fingers, cascading back down to the dune. Now look down the beach. It stretches for miles, curving around the coast, filled with billions upon billions of grains of sand. Now imagine every beach on Earth, every dune in the Sahara, every shoreline of every island, every riverbed. The number of grains is impossible to count, a number so large it becomes abstract, a concept of infinity. Astronomers tell us that there are more stars in the universe than there are grains of sand on all the beaches of Earth combined. Let that feeling sink in, the feeling of abundance. The universe is not empty, it is crowded with light. We reside in the Milky Way galaxy alone with hundreds of billions of stellar companions. And beyond our galaxy, there are hundreds of billions of other galaxies, each a swirling island of billions of stars. If you could float outside of our reality and look down upon the cosmos, it would not look dark. It would look like a shimmering web of luminescence, a grand, glowing structure where darkness is merely the space between the lights. This abundance reminds us that there is no scarcity in nature. There is only endless creation, endless energy, and endless possibility. stretching out forever in all directions. Where do these countless stars come from? From the abundance of the mature stars, we drift softly to the cradles of the cosmos, the stellar nurseries. In the vast open spaces between existing stars, there drift colossal clouds of dust and gas known as nebulae. Visualize a cloud, not like the fluffy white ones of Earth, but a towering, majestic structure of deep purples, vibrant pinks, and swirling blues, illuminated from within. These are the wombs of the stars. They are regions of profound silence and slow motion, where the universe is knitting together new suns. Picture the process as a slow, gentle gathering. Gravity, the patient sculptor, begins to pull the dust and gas together. A small pocket of density forms, a knot in the fabric of the cloud. Slowly, over millions of years, this knot pulls in more material, growing heavier, spinning faster, heating up. It is like a snowball rolling down a hill, gathering mass, or a whirlpool in a dark river. Deep inside these dark, opaque clouds, the pressure builds until, igniting like a match struck in a dark room, a new star turns on. It bursts forth, blowing away the remaining cocoon of dust with its fierce newborn wind, revealing itself to the galaxy. To look at a nebula is to witness the morning of creation, to see the very moment when the universe decides to light a new candle against the dark. When these candles are lit, they do not all burn with the same light. As we observe the night sky more closely, we begin to notice subtle differences in hue. For stars are the jewels of the cosmos, and they come in many colours. We are used to our yellow sun, and we often think of stars as white. But if you look with a steady, relaxed gaze, you will see the spectrum. The colour of a star is a direct language, whispering to us about its temperature. It is contrary to what our intuition about water taps might tell us. In the celestial realm, blue is the colour of the fiercest heat, and red is the colour of a cool, simmering burn. Imagine a blacksmith's forge. As the metal heats, it turns dull red, then bright orange, then yellow, and finally, when it is hottest, it glows a blinding white blue. The stars follow this same ancient law of physics. High above, the star Rigel burns with a piercing, icy blue intensity, hot and young and ferocious. In contrast, the star Betelgeuse glows with a sombre, rusty red-orange, a cool giant in the twilight of its life. Between them lie the yellow stars like our sun, and pure white stars balanced and steady. Visualize a jewellery box overturned on black velvet, sapphires, rubies, topazes, and diamonds scattered in a haphazard, breathtaking array. This variety brings a richness to the dark, a reminder that fire expresses itself in many forms, each beautiful, each necessary to complete the painting of the night. Among these colourful jewels there is a class of stars that dominates the population, though they are shy and hide from our naked eyes. These are the Red Dwarfs. Imagine a small, cosy campfire, one that has burned down to the embers. It is not roaring or aggressive, it just glows with a steady, comforting, ruddy warmth. These are the Red Dwarfs. They are much smaller than our sun, often only a fraction of its size, and they burn their fuel at a miserly slow pace. Because they are so small and sip their fuel so gently, they are dim, invisible to us without a telescope, yet they are the most common stars in the galaxy. There is a profound comfort in the existence of red dwarfs because of their longevity. While massive, bright blue stars might burn out in a few million years, living fast and dying young, the red dwarfs are the tortoises of the universe. They burn so slowly that they can live for trillions of years. They will outlast our sun. They will outlast the current structure of the galaxy. Long after other lights have faded, these small red embers will continue to glow, keeping the vigil in the dark. They represent patience, endurance, and the strength of a quiet, steady presence. They remind us that one does not need to be the brightest or the loudest to be the most enduring. Sometimes, a soft, steady glow is all that is needed to survive the eons. From the solitary vigil of the red dwarves, we drift to a different kind of stellar existence, one of partnership and duality. We often think of stars as solitary wanderers, like our own sun, ruling its system alone. But in truth, the universe loves company. A vast number of the points of light you see are not single stars at all, but binary systems. Two stars locked in a gravitational embrace, orbiting a common centre of gravity. Picture two dancers in a grand ballroom, hands clasped, spinning around one another. They never touch, yet they are forever bound, moving in perfect synchronization through the void. Some of these pairs are mismatched, a giant red star waltzing with a tiny white companion. Others are twins, mirroring each other's brilliance. Imagine standing on a planet orbiting such a system. You might witness a double sunrise, where a red sun rises first, bathing the world in crimson light, followed by a blue sun that changes the shadows to violet. It creates a sky of shifting colours and complex rhythms. This celestial dance speaks to the balance of forces, the way gravity binds objects together in relationships that last for billions of years. It is a comforting thought that even in the vastness of space, isolation is not the rule. Companionship, gravity, and mutual attraction weave the stars together in a graceful, eternal ballet. As we look back at these stars from our vantage point on Earth, we notice something that belongs not to the stars themselves, but to the air we breathe. We see them twinkle. This is the scintillation, the winking of the stars that has inspired nursery rhymes and poets for millennia. But let us visualize what is truly happening. The light from a star streams steady and true across light years of emptiness. It is a straight, unwavering beam, but just before it reaches your eye, it must pass through the blanket of Earth's atmosphere. Our atmosphere is an ocean of air, with currents, temperature layers, and shifting winds, much like a pool of water. Imagine tossing a bright silver coin into the deep end of a swimming pool. As you look down at it through the rippling water, the coin appears to shift, wobble, and flash. The coin itself is still, but the medium through which you view it is in motion. This is the twinkling of a star. It is the turbulence of our own home distorting the steady message from the cosmos. The planets, being closer and appearing as tiny disks rather than pinpoints, generally do not twinkle. They shine steadily. So, when you see that gentle flickering, that rapid pulse of brightness, know that it is the signature of the air that keeps you alive, dancing with the light from the deep, creating a living connection between the ground you lie on and the vacuum of space. Finally, the human mind, ever seeking patterns in the chaos, takes these twinkling points of light and draws lines between them. We arrive at the concept of constellations. Since the dawn of consciousness, humans have looked up and played a cosmic game of connect the dots. We projected our heroes, our monsters, our tools, and our gods onto the dark canvas. Visualize the night sky not as a random scattering, but as a storybook. There is the great hunter, Orion, with his belt of 3 stars. There is the great bear, Ursa Major, guarding the north. There is the swan, Cygnus, flying down the river of the Milky Way. These shapes are not physically connected. The stars in a constellation may be light years apart, having no relation to one another in deep space. One might be a neighbour to us, and the one next to it might be on the other side of the galaxy. Yet, from our perspective, our unique vantage point on this little blue marble, they align to form a picture. This is a testament to the power of perspective and imagination. It transforms the cold, indifferent void into a familiar neighbourhood. When you look up and recognise a constellation, you're sharing a gaze with ancestors from thousands of years ago, seeing the same shapes, finding the same comfort in the order of the sky. It anchors us in history, reminding us that though the world changes, the stars remain our steadfast, silent storytellers, waiting every night to be read again. And just as those ancient lines drawn by our ancestors connect the stars into familiar shapes, there is one star that serves as the anchor for the entire celestial sphere, a singular point of stillness in a turning world. If you were to stand in a vast open field and watch the night sky for hours, time-lapse style, you would see the entire dome of heaven slowly rotating, a grand carousel of light spinning around one precise spot. Here sits the North Star, Polaris. While all other stars rise in the east and set in the west, travelling great arcs across the dark, Polaris remains steadfast, virtually motionless in the northern sky. It is the pivot around which the galaxy seems to dance. Visualize a great spinning wheel, and you are resting comfortably at the very centre of the hub, where the motion is almost imperceptible. This is the energy of the North Star. For thousands of years, sailors on dark, turbulent oceans looked up to this single point of light to find their way home. It is the celestial symbol of guidance and reliability. It whispers to us that no matter how much the world spins around us, no matter how chaotic the winds or how shifting the tides, there is always a fixed point, a true north that does not waver. Let your mind rest on this image of stability, a bright, unwavering beacon holding the sky in place, promising that you can never truly be lost as long as you know where to look for the light. It is a lighthouse that never blinks, a guardian that never sleeps, holding the roof of the world up while you drift down into dreams. As we widen our gaze from this single steady anchor, we begin to perceive the faint milky glow that arches across the entire sky, the river in which all these stars are swimming. This is our home, the Milky Way. To the ancients, it looked like a stream of milk spilled by a goddess across the obsidian floor of the night, or a pathway of souls leading to the afterlife. But we know it now as a colossal island of stars, a spiralling city of light disc-shaped and vast beyond comprehension. Imagine yourself floating high above this structure, looking down upon it. It resembles a glowing pinwheel swirling slowly in the silence of the void, its arms composed of mist and fire, wrapping gently around a bright, dense core. We live in the suburbs of this great galactic city, tucked away in one of the quiet spiral arms, far from the bustling, crowded centre. To see the Milky Way on a clear, moonless night is to look into the edge of our own saucer, seeing the collective glow of billions of distant suns masked by the dust lanes of interstellar space. It looks like a band of diamond dust, a soft, pearlescent cloud that divides the darkness. Visualize floating on a raft down this silent river of light. The current is slow and gentle. There is no sound, only the shimmer of the banks lined with stars. It brings a sense of belonging to realize that we are part of this massive, cohesive structure, traveling together through the universe. We are not isolated specks. We are passengers on a magnificent vessel, a galaxy of light sailing through the dark ocean of the cosmos. Within this galactic city, the inhabitants vary wildly in size, and as we drift deeper, we encounter the true titans of the universe, the supergiant stars. Our own sun, which seems so massive to us, is merely a grain of sand compared to these behemoths. Imagine a star so colossally vast that if you placed it in the centre of our solar system, its surface would extend out past the orbit of Jupiter, swallowing all the inner planets, including Earth, whole. These are stars like Betelgeuse and VY Canis Majoris, the emperors of the sky. Try to visualize the sheer scale of such an object. It is a burning sphere of gas so large that it would take an airplane over 1,000 years to fly around its equator. These stars live fast and burn with a terrifyingly beautiful intensity. They are not dense and compact like our sun, but puffy, ethereal and tenuous, their outer layers billowing out like red smoke into the vacuum. To float near one would be to face a wall of fire that stretches up and down forever, occupying your entire field of vision. Yet, despite their intimidating size, they are gentle giants in a way. Their outer atmosphere is so diffuse that they're almost like a hot vacuum. Contemplating these giants stretches the mind, pushing the boundaries of what we believe is possible, reminding us that reality is far grander, far larger, and far more majestic than our small daily lives on the ground. But even giants must eventually rest, and the life cycle of these massive stars leads us to one of the most spectacular events in nature, the supernova. It is a violent word, but here, in the safety of your imagination, visualize it as a blooming flower. When a massive star runs out of fuel, it can no longer support its own immense weight. In a fraction of a second, the core collapses inward, and then, with a bounce of unimaginable power, it explodes outward. This is not destruction in the sense of an ending, but rather a transformation, a cosmic seed pod bursting open. For a few weeks, a single supernova can outshine an entire galaxy of billions of stars. It is a flashbulb popping in the dark cathedral of space. Visualize the shockwave, a grand, expanding ring of iridescent gas, glowing in neon shades of teal, violet, and gold, travelling outward at millions of miles per hour. It sweeps through the interstellar medium, compressing gas clouds, waking them up, and triggering the birth of new stars. It is the circle of life written in fire. The death of one great star becomes the catalyst for the birth of hundreds of new ones. It is a reminder that in the universe, nothing ends without beginning something else. The energy is released, the materials are scattered, and the cycle continues, a heartbeat that spans millions of years, pulsing with the rhythm of creation and release. And what is it that these exploding stars scatter into the dark? This brings us to a fact that is perhaps the most intimate and profound of all, the connection between the stars and your own body. This is the concept of stardust. Inside the fiery crucible of those massive stars, and in the heat of their explosive deaths, the universe forges elements. The hydrogen and helium of the Big Bang are fused into heavier things: carbon, oxygen, nitrogen, iron, calcium. When the star explodes, it flings these precious materials far and wide, seeding the galaxy with the building blocks of life. Consider the blood that flows through your veins right now, carrying oxygen to your resting muscles. The iron in that blood, the very element that makes it red, was forged in the dying heart of a star billions of years ago. The calcium that knits your bones together into a strong frame was cooked in a stellar furnace. The carbon that forms the complex chains of your DNA was once floating in the atmosphere of a giant sun. You're not merely living in the universe. You are the universe. You're a way for the cosmos to know itself. Every atom in your body has travelled through the vacuum of space, has been part of a burning nebula, has seen the birth of worlds. Feel the weight of that heritage. You are ancient, you are stellar, you're made of light and time, temporarily holding this human shape before eventually returning to the flow. Sometimes, when a massive star collapses, it leaves behind something incredibly dense, a core that refuses to fade away completely. These are the neutron stars. Imagine taking a star twice the mass of our sun and crushing it down until it is the size of a small city, perhaps only 12 miles across. The density is mind-bending. A single teaspoon of a neutron star would weigh as much as a mountain, billions of tons. In this realm, matter is packed so tightly that atoms dissolve, leaving only a soup of neutrons. These city-sized stars spin rapidly, born from the pirouette of the collapsing giant. Some of them spin hundreds of times every second, beaming out jets of radio waves like a cosmic lighthouse. These are called pulsars. If you could listen to the radio sky, you would hear them, a steady rhythmic beat. Tick, 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 or a fast hum like a hummingbird's wing. They are the timekeepers of the galaxy, the metronomes of the deep dark. Visualize this dense, smooth sphere, spinning in the silence, a perfect geometric shape with a surface smoother than a billiard ball. There is something hypnotic about their rotation, a precision that defies the chaos of nature. Let the idea of that steady, unfaltering rhythm soothe your mind, a background pulse that keeps the beat of the universe while you drift into the quiet. If the collapsing star is even larger, it leaves behind a mystery that physics is still struggling to whisper about: the black hole. While the name sounds empty, it is actually the opposite. It is a region where matter is packed into a space of zero volume. It is an embrace of gravity so strong that not even light can escape it. Visualize it not as a monster, but as a place of ultimate rest. A point where the fabric of space and time curves infinitely inward, like a waterfall cascading into a deep, dark pool. Around the black hole is the event horizon, the point of no return. But from a distance it appears as a sphere of absolute darkness, silhouetted against the starry background. It bends the light of the stars behind it, creating a halo, a ring of warped starlight. Near this object, time itself begins to slow down. If you were to drift closer, your watch would tick slower and slower compared to the outside world, until, at the very edge, time seems to stand still. It is the ultimate pause button. In a world that is always rushing, always moving, the black hole represents the concept of the eternal now, a place where the clock stops, where the noise fades, and where the universe holds its breath forever. It is the deepest silence imaginable, a velvet curtain drawn across the window of reality. Not all stars end in explosions or exotic collapses. Some objects form in the nebulas but never quite gather enough mass to ignite the fusion fires of a true star. These are the brown dwarfs, the failed stars, though perhaps it is kinder to think of them as the bridge between stars and planets. They are larger than Jupiter but smaller than the Sun, existing in a permanent state of twilight. They do not shine with blinding white light. Instead, they glow with a dull magenta or deep purple hue, emitting warmth but very little visible light. Imagine a world that is essentially a giant warm ember. If you were to float near a brown dwarf, you would see a surface covered in bands of clouds, swirling storms of molten iron and silicate rain. It is a place of heavy, dark weather. These objects are the introverts of the galaxy, sitting quietly in the dark, warm and heavy, neither burning bright nor freezing cold. They represent the middle path, the balance. They remind us that one does not always have to shine brilliantly to exist. There is value in simply being, in holding warmth, in existing in the spaces between the extremes. They are the cozy, dim corners of the universe, hiding in the shadows, waiting to be found. Around the true stars, however, there is often a zone of perfect balance, a region that astronomers call the habitable zone, or more delightfully, the Goldilocks zone. This is the specific distance from a star where it is not too hot, so water doesn't boil away, and not too cold, so water doesn't freeze into ice. It is the zone where water can flow as a liquid, just right. Every star has this zone, a ring of potential around it. Visualize our own sun and the comfortable orbit of Earth. We're surfing on this perfect wave of temperature. It is a fragile, beautiful boundary. Imagine looking at other stars and seeing these invisible rings around them, the safe harbours where life might take hold. It is a welcoming thought that the universe creates these pockets of hospitality. It is not all fire and ice. There are temperate shores waiting for travellers. It invites us to dream that we're not alone, that somewhere else, under the light of a different sun, there might be other oceans, other forests, and perhaps other dreamers looking up at their own sky, wondering about us. It connects us through the possibility of life, a chain of just right worlds scattered through the void. Finally, the connection between a star and its worlds is not just about heat and light. It is a physical touch. Our sun breathes. It constantly exhales a stream of charged particles known as the solar wind. This wind rushes out in all directions, washing over the planets. When this solar breath reaches Earth, it meets our magnetic shield, and the result is one of the most ethereal displays of beauty known to nature, the auroras. Visualize the North Pole, a landscape of snow and ice, silent and white. High above, the invisible wind from the sun strikes the upper atmosphere. Suddenly, the sky begins to dance. Curtains of neon green, pale pink, and deep violet shimmer into existence. They ripple and fold like silk sheets blowing in a slow-motion breeze. This is the aurora borealis, the northern lights. It is the visible signature of the sun interacting with the earth. It is a cosmic conversation, a transfer of energy that paints the night. To lie under these lights is to watch the sky breathing, to see the invisible forces of the universe rendered in colour. It is a gentle, silent firework display that requires no gunpowder, only the breath of a star and the shield of a planet dancing together in the dark, reminding us that there is magic in the interaction of things, beautiful consequences to the invisible forces that surround us. This dance of light above the poles is merely the visible edge of a much grander embrace, for the sun's influence extends far beyond the auroras, creating a vast protective bubble around our entire solar system. This is the heliosphere. Imagine a ship sailing through a dark, calm ocean, pushing the water aside to create a bow wave that travels ahead of it. Our sun is that ship, moving through the galaxy, and the solar wind blows a colossal bubble of plasma that shields us from the harsher, colder winds of interstellar space. Visualize yourself floating at the very edge of this bubble, a place called the heliopause. It is billions of miles away, far past the orbit of Pluto. Here, the solar wind finally slows down and merges with the currents of the rest of the galaxy. Inside this bubble, we're held in a warm magnetic cocoon, safe from the high-energy cosmic rays that streak through the void. It is a comforting thought to realize that our entire family of planets, Earth, Mars, Jupiter, and the rest, are all travelling together inside this invisible hull. We're not exposed to the raw elements of the universe. We are protected, carried within a sphere of solar influence that acts as a womb, keeping the chaotic energies of the deep cosmos at bay while we drift through the spiral arms of the Milky Way. While the sun protects us with its wind, it also hides its most delicate feature from our daily view, revealing it only during a moment of perfect alignment. We drift now to the phenomenon of the solar eclipse and the revelation of the corona. Under normal circumstances, the sun is too bright to look at, a blinding disk of dominance. But every so often, the moon slides perfectly in front of the star, a cosmic coincidence of size and distance that blocks the fierce central glare. In that moment of sudden twilight, when the birds go quiet and the air cools, a ghostly halo appears around the black circle of the moon. This is the solar corona, the sun's crown. It is a wreath of pearly white light, wispy and ethereal, stretching out into space like the petals of a celestial flower. Unlike the yellow surface we know, the corona is a texture of fine, silken strands, magnetic field lines glowing with superheated plasma. Visualize this halo shimmering in the darkened sky. It looks soft like white velvet or spun sugar, yet it is hotter than the surface of the sun itself. It is a reminder that beauty often hides behind brilliance. Only when the overwhelming light is dimmed can we see the delicate, ghostly atmosphere that has been there all along, dancing in the silence, crowning our star with a diadem of white fire. If we were to peel back this crown and look closer at the surface of the sun itself, we would find that it is not a flawless, uniform complexion. It is marked with beauty marks known as sunspots. Imagine looking down at a vast ocean of gold and orange fire and seeing dark, calm islands floating in the churn. These spots appear black to our eyes, but only by contrast. If you could pluck one off the star and place it in the night sky, it would shine brighter than the full moon. They are simply cooler than the raging inferno around them, regions where the star's magnetic field has become knotted and tense, inhibiting the flow of heat from below. There is a serene quality to these blemishes. They drift across the face of the sun like clouds changing shape, growing and shrinking over days and weeks. They are the visible footprints of the magnetic dynamo churning deep inside. To visualize a sunspot is to see a storm of silence, a dark umbra surrounded by a lighter penumbra that looks like the iris of a giant golden eye. They remind us that even the stars in their perfection have textures and cycles, changing their faces as they rotate. These spots ebb and flow in an 11-year rhythm, a slow, decadal heartbeat of activity that pulses through the solar system, subtly altering the weather of space. Rising from these magnetic regions, we witness one of the most graceful structures in the universe, the solar prominence. The sun is not merely a ball of fire, it is a loom of magnetism. Often, huge loops of glowing plasma will lift off the surface, tracing the invisible magnetic field lines that arc high into the corona. Visualize a bridge of fire, a glowing red archway grand enough for the entire Earth to pass underneath without touching the sides. These are not fleeting sparks. They can hang suspended in the solar atmosphere for weeks, glowing steadily against the blackness of space. Imagine floating near one of these great arches. It is a slow-motion fountain. The plasma flows up one leg of the loop, travels across the high span, and rains back down the other side, following the magnetic guide rails. It is a river of fire defying gravity, suspended by the invisible forces of the star. Sometimes these loops twist and snap, releasing energy, but often they simply exist as monuments of light, silent Torii gates standing on the edge of the sun. They demonstrate the fluidity of the star, showing us that it is not solid rock, but a living, moving body of gas and fields, constantly sculpting itself into shapes of awe-inspiring geometry. We often think of stars as silent objects because space carries no sound to our ears, but in truth, stars are giant musical instruments. This brings us to the concept of astroseismology, the study of the songs of the stars. The interior of a star is a turbulent, boiling place, and this movement creates sound waves that bounce around inside the sphere. These waves cause the star to vibrate, to expand and contract minutely, ringing like a colossal bell struck by a cosmic hammer. If we could translate these vibrations into human hearing, we would hear a deep, resonant hum, a bass note lower than anything an earthly organ could produce. The sun has a heartbeat. It has a rhythm. Millions of different sound waves are trapped inside it, creating a complex symphony of resonances. Visualize the star not just as a light, but as a singing bowl, vibrating with the energy of its own creation. This music of the spheres is real. The frequencies tell us about the star's core, its age, its future. It adds a layer of sensory depth to the cosmos. To know that the night sky is not actually silent, but filled with the deep, throbbing hum of billions of stars, each singing its own unique song into the vacuum. While some stars hum quietly, others breathe visibly. These are the variable stars, the lighthouses of the galaxy. Unlike our sun, which shines with a relatively steady light, these stars possess a rhythmic cycle of brightening and dimming. The most famous of these, the Cepheid variables, are like cosmic lungs. Visualize a star that physically swells up, growing larger and cooler, and then exhales, shrinking down and becoming hotter and brighter. This cycle repeats with the precision of a clock, expanding and contracting, expanding and contracting. Imagine looking up at the night sky and seeing a star that slowly winks at you over the course of a week. It fades to a faint glimmer, then slowly, day by day, rekindles its fire until it is brilliant again. This reliability is a comfort to astronomers. They use these pulsing stars as mile markers to measure the size of the universe. But for the dreamer, they represent the quality of change and return. They are the rhythmic breathers of the dark, demonstrating that the universe is alive with motion. Nothing is stagnant. Even the stars are breathing, keeping time in the deep silence, a pulse that beats across the light years to reach our eyes. And just as the stars breathe, they also wander. We tend to think of the constellations as fixed, eternal pictures frozen on a wall, but this is an illusion of our short lifespans. In reality, every star is drifting, possessing what astronomers call proper motion. The sky is a slow-moving river. If you could press a fast-forward button and watch 1,000,000 years go by in a minute, you would see the familiar shapes of the Big Dipper, and Orion distort and break apart. The stars are travelling in different directions, some rushing toward us, others drifting away, each on its own unique orbit around the galactic centre. Visualize the night sky as a grand, fluid ballet. The stars are like fireflies lazily drifting across a dark meadow. Barnard's star, a faint red neighbour, moves so quickly it is called a runaway, shifting its position noticeably within a single human lifetime. This concept frees us from the idea of a static universe. We are looking at a snapshot of a moment in time. The patterns we see tonight will never be seen in exactly the same way again. It is a slow, graceful drift, a reminder that we are all travellers, all moving through the void, and for a brief moment our paths have aligned to create the beautiful, temporary tapestry we see tonight. In this drifting ocean, stars often find comfort in numbers, gathering together in spectacular formations. One of the most ancient and beautiful of these is the globular cluster. Imagine a spherical swarm of stars, a tight ball of light hovering in the halo of the galaxy. These clusters are the ancient cities of the universe, some of them nearly as old as the cosmos itself. Inside a single cluster, hundreds of thousands, sometimes millions, of stars are packed into a relatively small space. If you lived on a planet inside a globular cluster, you would never know true night. The sky would be ablaze with thousands of stars brighter than Venus, casting shadows even when your main sun was down. It would be a ceiling of diamonds, a glittering jewellery box spilled open. These stars are mostly old, red and gold, glowing with the steady light of maturity. They are bound tightly together by gravity, holding on to one another for billions of years. Visualize this dense, glowing hive, a sanctuary where stars live in close community, a dazzling ball of light floating in the silence, preserving the history of the early universe in their golden glow. In contrast to these ancient golden cities, we also find the open, breezy nurseries of the open clusters. These are the families of young siblings, stars that were born together from the same nebula and are now travelling through space as a group. The most famous of these is the Pleiades, the Seven Sisters, a delicate shimmer of blue light that catches the eye in the winter sky. Unlike the tight, spherical, globular clusters, open clusters are loose and irregular, like a flock of birds scattering into the wind. Visualize a handful of bright sapphire blue jewels cast onto black velvet. These stars are young, hot, and fierce. They're often still wrapped in the wisps of the gas clouds that birthed them, creating a soft blue reflection nebula that glows around them like a halo of mist. To look at the Pleiades is to look at youth and potential. These siblings will eventually drift apart, pulled by the galaxy's tides to travel their own paths, but for now, they shine together. There is a sense of freshness in these clusters, a cool, crisp blue light that cuts through the dark, reminding us of new beginnings and the bond of shared origins. Eventually, the journey of a star leads to a transformation, and for stars like our Sun, this final act creates one of the most artistic displays in the cosmos, the planetary nebula. Do not let the name fool you. This has nothing to do with planets. It is the death shroud of a star, but it is a shroud of breathtaking beauty. When a medium-sized star reaches the end of its life, it gently puffs its outer layers into space, exhaling its atmosphere to create a glowing shell of gas. Visualize a ring of glowing smoke, expanding slowly into the dark. These nebulae form intricate shapes, hourglasses, butterflies, eyes and rings, painted in vivid hues of aquamarine, emerald green and ruby red. At the very centre sits the tiny hot white dwarf, the remaining core of the star, illuminating the gas from within like a light bulb inside a paper lantern. This is a peaceful passing. It is not an explosion, but a release. The star gives its substance back to the universe, creating a sculpture of light that hangs in the void for thousands of years. It represents the ultimate act of giving, the transformation of a single point of light into a vast, colourful monument that seeds the cosmos for the next generation of stars. It is a silent, glowing goodbye that is more beautiful than the star ever was in life. And at the centre of this expanding flower of gas, stripping away its veils of coloured smoke, lies the exposed heart of the star, a small, incredibly dense object known as a white dwarf. Imagine an ember that has been taken out of a roaring fire and placed on a stone hearth. It no longer has the fuel to generate new flames, but it still glows with the intense stored heat of its former life. This is the fate of our own sun, billions of years from now. A white dwarf is a marvel of compression. Imagine packing the entire mass of the sun, all that fire, all that gravity, into a sphere no larger than the Earth. To stand on the surface of a white dwarf would be impossible, for the gravity is crushing, but in our minds we can float safely above it. It glows with a fierce, brilliant white light, a testament to the heat trapped within. It is a star in retirement, no longer fighting the battle against gravity, no longer fusing atoms. It is simply resting, slowly radiating its warmth out into the cold universe. There is a profound stillness here, a sense of a job well done. After billions of years of burning, of holding the solar system together, of nurturing life, the star has shed its outer layers and settled into a long, quiet sleep. It is a compact jewel shining steadily, a beacon of memory that will persist for eons, slowly fading as the ages of the cosmos roll by. As these white dwarfs cool over billions of years, a transformation occurs deep within their hearts that is more beautiful than any treasure on Earth. The core of these stars is made largely of carbon and oxygen, the ashes of the helium fusion that once powered them. Under the unimaginable pressure of the star's gravity, as the heat slowly bleeds away, this carbon begins to organise itself. It crystallises. Just as coal can be pressed into diamond deep within the Earth, the heart of a white dwarf turns into a single, colossal diamond. Visualise a crystal the size of a planet. It is not a diamond like the small cut stones in a ring, but a raw lattice structure of pure crystallised carbon, pulsating with a faint resonant hum. Astronomers have found such stars, giving them names like Lucy, in the sky with diamonds. Imagine the light passing through such a structure, refracting and prismatic, a core of solid brilliance hidden beneath a thin atmosphere of hydrogen. It is the ultimate alchemy of the universe, taking a chaotic, burning ball of gas and, through the patience of time and the pressure of gravity, transforming it into the hardest, most enduring substance known to nature. It suggests that in the end, chaos resolves into order and fire resolves into crystal beauty. But the timeline of the stars is vast beyond human comprehension, and even a white dwarf with its diamond heart is not the final chapter. We drift now to a concept that exists only in the far, deep future, a theoretical object known as a black dwarf. Because white dwarfs are so hot and release their heat so slowly, the universe is simply not old enough for any of them to have cooled down completely yet. But trillions of years from now, long after the current era of galaxies has faded, these stars will finally radiate away their last photon of light. Visualizing a black dwarf is an exercise in perceiving the ultimate peace. It is a star that has become perfectly dark, a cold crystal sphere floating invisibly in the void. It emits no light, no heat. It is a stellar ghost, a monument to the light that once was. It drifts through the eternal darkness, unseen and undisturbed. While this might sound somber, there is a deep comfort in the idea of a rest so complete that it lasts forever. It is the stillness at the end of all motion, the silence at the end of the song. It reminds us that everything, even the stars, eventually finds a place of perfect equilibrium, where there is no more energy to be spent, only existence in its purest, most quiet form. While the stars themselves evolve and change, they are also travellers on a grand scale. We often feel that we are sitting still, but we are actually passengers on a carousel of immense proportions. This is the concept of the galactic year. Just as the Earth takes 1 year to orbit the Sun takes approximately 230 million years to complete one orbit around the centre of the Milky Way. We are moving at incredible speeds, surfing the spiral arms of the galaxy, yet the ride is so smooth, we feel nothing. Cast your mind back to the last time we were in this exact spot in the galaxy. It was not the time of the pyramids, nor the time of the cave painters, it was the Triassic period. The first dinosaurs were just beginning to walk the Earth. The continents were fused together into the supercontinent of Pangaea. Flowers had not yet evolved. Since then, we have travelled a full circle, sweeping through the dark voids, passing through star clusters, and witnessing the birth and death of nebulas, only to arrive back here. The galaxy is a clock of deep time. Each tick is an era, each tock is an epoch. Feeling this motion anchors us in the grand rhythm of the cosmos. We are not static, but part of a majestic, slow-turning wheel that cycles through history, carrying us on a voyage that is millions of years long. And where are we headed on this voyage? If you were to stand at the prow of our solar ship looking forward into the cosmic wind, you would be facing the beautiful blue-white star Vega. This point in the sky is known as the solar apex. It is the direction of our sun's travel through the local interstellar cloud. We are not wandering aimlessly. We have a heading. The entire solar system, planets, moons, asteroids, and you, is rushing toward the constellation of Lyra at some 45,000 miles per hour. Visualize this forward motion. Imagine the sun as a comet trailing the planets behind it like a golden tail, cutting through the thin mist of the interstellar medium. The bow shock of our heliosphere pushes aside the dust and gas, clearing a path for us. There is a sense of purpose in this movement, a feeling of being on an expedition into the unknown. We will never reach Vega, for it is moving too, but it serves as our North Star for this leg of the journey. It is a reminder to look forward, to understand that life is a trajectory, a constant movement into new spaces, new experiences, and new starlight. As we travel, we look out at the other stars passing by, and for centuries we wondered if they were lonely, like our sun was once thought to be. Now we know that the universe is teeming with companions. This brings us to the discovery of exoplanets, and specifically, the gentle method we use to find them, the transit. Imagine you're watching a distant lighthouse on a dark coast. The beam is steady and bright, but every so often a small moth flies in front of the lantern. For a brief second the light dims, just a tiny fraction, before returning to full brightness. This is how we find worlds. We stare at a star and wait for it to wink at us. When a planet crosses the face of its sun, it casts a tiny, desperate shadow across light years of space to reach our telescopes. Visualize that shadow sweeping over us. It is a shadow of a world that might have oceans, clouds, mountains, perhaps even eyes looking back at us. This method requires patience and precision, a staring contest with the cosmos. It turns the night sky into a place of hidden treasures, where every flicker of light could be the signature of a hidden world, a silent announcement that here too is a place where gravity holds a sphere, where a sun rises and sets. Among these hidden worlds we have found places that defy our earthly imagination, planets that are locked in a permanent embrace with their stars. These are the tidally locked worlds. Imagine a planet so close to its star, or influenced by such strong gravity, that it no longer spins freely. One side of the planet faces the star forever, locked in eternal scorching day. The other side faces the freezing void, locked in eternal frozen night. These are worlds of extremes, where the sun never rises and never sets. It simply hangs motionless in the sky, a great burning eye. But between the burning day and the frozen night, there is a ring of twilight that circles the entire planet. This is the Terminator Zone. Visualize standing in this band of eternal dusk. The sun sits forever on the horizon, painting the sky in perpetual shades of deep violet, bruised orange, and soft pink. Here, the temperature might be mild, a spring evening that never ends. The winds would flow constantly from the day side to the night side, carrying the heat, creating a weather system of eternal consistency. It is a world of shadows and soft light, a place where time seems to lose its meaning because the cycle of day and night has vanished, leaving only the everlasting gloaming. Drifting further into the catalogue of these alien worlds, we encounter the super-Earths. These are rocky planets like ours, but scaled up, massive and imposing. Imagine a world twice the size of Earth, with gravity that pulls stronger, making everything feel heavier and more grounded. On such a world, the mountains might be lower, crushed down by the weight, but the atmosphere could be thick and rich, a blanket of clouds that wraps the planet in mystery. Visualizing a super-Earth is an exercise in grandeur. Picture vast, flat plains of basalt stretching to a horizon that seems further away than it should be, because the curve of the planet is more subtle. The volcanoes here would be colossal, pumping heat from a core that remains molten for longer than our own. These are the big brothers of our home, sturdy and resilient. They remind us that nature plays with scale, creating variations on a theme. A super-Earth represents stability, a solid footing in the chaos of space, a rock that can hold onto its atmosphere for billions of years, providing a long, stable stage for whatever drama of chemistry might unfold on its surface. In contrast to the rocky giants, there are worlds where no land breaks the surface at all. These are the ocean worlds, or Hycean planets. Imagine a planet completely covered in water, a global ocean thousands of miles deep. There are no continents, no islands, no beaches, only the endless rolling rhythm of the waves. The water might be dark blue, or perhaps teal, reflecting the light of a nearby red dwarf star. Dive into this imagination. Below the surface, the water is warm, heated by the planet's core. Without the barriers of continents, the currents here would be majestic, sweeping around the globe in uninterrupted streams. The silence would be absolute, save for the sound of the water itself. It is the ultimate symbol of the unconscious, a depth that has no bottom, a surface that mirrors the stars. To float on such a sea would be to float between two infinities, the abyss of the ocean below and the abyss of space above, held in the cradle of the liquid element that is the prerequisite for all life as we know it. Finally, let us return from these distant worlds to the horizon of our own home, to witness a phenomenon that connects our eyes, our atmosphere, and our star in a fleeting moment of magic. This is the green flash. It is a rare gem of the sunset. As the sun dips below the horizon over a calm ocean, the atmosphere acts like a prism, separating the sunlight into its colours. The red and orange light bends one way, the blue and violet are scattered, and for a split second, the very top edge of the sun turns a brilliant electric emerald green. It happens in the blink of an eye, a pulse of pure green light just as the sun vanishes. To see it, one must be patient, watchful, and calm. It is a reminder that the boundary between day and night is not just a line, but a transition filled with hidden colours. Visualize sitting on a quiet beach, the sound of the waves rhythmic and slow. You watch the golden disk sink, lower, lower, until it is just a sliver, and then, flash, a spark of green, and then the twilight takes over. It is nature's wink, a secret shared between the star and the observer, a promise that even in the most familiar daily event, the sunset, there is still room for surprise, for wonder, and for a sudden, unexpected burst of beauty before the stars come out to watch over your sleep. As the green flash fades into the memory of the horizon and the twilight deepens into true night, a subtle, ghostly glow sometimes remains, stretching upward from the place where the sun vanished. This is the zodiacal light, often called the false dawn when seen before sunrise. Imagine a tall, faint pyramid of pearly white light, soft as breath, leaning against the darkness of the sky. It is not the light of a star nor the glow of the atmosphere, but something far more ancient and ethereal. visualize the space between the planets, the vast emptiness that we often think of as a vacuum. It is in fact filled with a tenuous glittering fog of interplanetary dust, microscopic grains of rock and ice left over from the construction of the solar system billions of years ago. When the angle is just right, sunlight reflects off these billions of tiny motes, creating a diffuse, illuminated pathway that traces the plane of our solar system. To see the zodiacal light is to see the scaffolding of our home, the dusty remnants of the nebula that birthed us. It is a reminder that we are floating in a dusty room, sunbeams catching the floating particles, creating a cathedral of soft light that marks the path where the planets wander. A silent, milky road paved with the history of our cosmic neighbourhood. Following this dusty road, our gaze is naturally drawn toward the thickest, brightest part of the Milky Way, the region where the river of stars seems to pool and deepen. We are looking toward the constellation of Sagittarius the Archer, but more specifically, we are looking into the galactic centre. Imagine standing on the edge of a great glittering city at night, looking toward the downtown district where the lights are clustered so thickly they merge into a single blaze. This is the heart of our galaxy, located some 26,000 light-years away from our quiet suburban arm. Here, the stars do not drift in solitary isolation, they swarm. The density of stars in the core is 1,000,000 times greater than in our local neighbourhood. If you lived on a planet in the galactic core, the night sky would be bright enough to read by, a dazzling canopy of thousands of suns. But between us and this brilliant centre lie great curtains of interstellar dust, thick clouds that obscure the view, turning the light red and dim, creating the dark rifts we see in the Milky Way band. It is a mysterious hidden place, a bustling metropolis of cosmic energy, veiled behind layers of velvet smoke. Visualize the sheer gravity of this place, the collective pull of billions of stars huddled together for warmth in the deep dark, a crowded, energetic dance floor where the galaxy celebrates its own existence. And at the very centre of this swirling dance, hidden behind the curtains of dust and the blaze of the star clusters, sits the great anchor of our spiral home, Sagittarius A. This is the supermassive black hole around which our entire galaxy turns. Do not visualize a monster, but rather a calm, silent pivot point, a heavy stone resting at the bottom of a deep, dark well. It is 4,000,000 times the mass of our Sun, compressed into a space no larger than a single solar system. It is the gravitational hub, the great attractor, that holds the spiral arms in their graceful winding shape. Around it, stars orbit at breakneck speeds, whipping around the invisible centre like moths circling a street lamp. Yet, despite this energy, the black hole itself is a region of profound silence and stillness. It is the eye of the storm. It represents the ultimate stability, a heavy, grounding force that keeps the galaxy from flying apart. There is a comfort in knowing that there is a centre, a defined point around which we all revolve. It anchors us in the void, providing a sense of orientation and balance to the great spinning disk of the Milky Way, ensuring that our journey through the universe is an organised, cohesive voyage rather than a chaotic drift. As we consider the stars that orbit this ancient centre, we begin to realise that not all stars are from the same generation. The universe has a lineage, a family tree written in light. This is the concept of stellar populations. Astronomers divide the stars into two great families, Population 1 and Population 2. It is a story of recycling and inheritance. Visualize the very first stars that ignited after the dawn of time. They were made of pure hydrogen and helium, pristine and simple. When they died, they forged the first heavy elements, metals, carbon, oxygen, and scattered them into the cosmos. The stars we see today, including our own sun, are the children and grandchildren of those ancient giants. We are Population 1 stars, metal-rich, born from clouds seeded with the dust of ancestors. Imagine looking at a golden star and knowing it is rich with the debris of the past. carrying the chemical legacy of the galaxy in its fiery atmosphere. In contrast, the ancient population 2 stars, found in the globular clusters and the galactic halo, are pale and metal-poor, the surviving elders of a bygone era. This distinction connects the stars in a cycle of birth, death, and rebirth. It reminds us that the universe is getting more complex, more flavourful, and more diverse with every passing eon. We are part of a lineage composed of recycled stardust, living in a solar system built from the gifts of those who came before. But not all objects born in the darkness stay within the warmth of a family system. Drifting silently between these populated star systems are the rogue planets, or planemos. These are the nomads of the galaxy, worlds that have broken free from the gravitational chains of their parent stars and have sailed out into the open ocean of interstellar space. Imagine a world like Jupiter or Earth, floating alone in the absolute dark, with no sun to rise in its sky. It sounds lonely, yet there is a serene beauty to these wanderers. Without a sun to bleach out the sky, the view from a rogue planet would be spectacular. A panoramic, unblemished view of the universe in every direction. These worlds are not necessarily frozen dead rocks. Many of them retain the heat of their formation deep within their cores, blanketed by thick atmospheres that trap the warmth. They are like deep-sea submarines, self-contained and warm on the inside, gliding through the cold currents of the void. They represent ultimate freedom, untethered and unbound, answering to no orbit, charting their own solitary course through the secret pathways of the night. They teach us that it is possible to carry your own warmth, to be a light unto yourself even in the deepest darkness. Far beyond the realm of the planets, at the very fringed edge of our own solar system, lies a structure that defines the boundary of our home, the Oort cloud. Visualize a colossal spherical shell made of billions of icy objects surrounding our sun like a thick frozen bubble. It is incredibly distant, so far away that the sun appears only as the brightest star in the sky, offering no warmth, only a piercing point of light. This is the freezer of the solar system, a vast reservoir of pristine ancient ice left over from the beginning of the world. The objects here drift in slow, lazy orbits that can take thousands of years to complete. It is a place of deep hibernation where history is preserved in cold storage. This shell acts as a boundary, marking the end of the sun's domain and the beginning of true interstellar space. It holds us in a gentle embrace, a cloud of potential energy and frozen memories waiting on the threshold of the void. To visualize the Oort cloud is to feel the vastness of our own backyard, to realize that the solar system is not just a flat disk of planets, but a giant three-dimensional sphere of influence that claims a massive volume of the dark for itself. Occasionally, a gravitational nudge from a passing star disturbs one of these icy sleepers in the Oort cloud, causing it to fall inward toward the sun. This begins the long, graceful journey of a comet. As this mountain of ice and dust plummets closer to the warmth, it begins to wake up. The ice sublimates, turning directly into gas, and the comet grows a majestic atmosphere, a glowing coma that surrounds the nucleus. Visualize this transformation, a cold, dark rock evolving into a brilliant celestial object. As it nears the sun, the solar wind brushes against it, sweeping the gas and dust backward into a tail that can stretch for millions of miles. This tail always points away from the sun, acting like a cosmic windsock. Comets are the messengers of the deep dark, bringing materials from the edge of the system to the inner sanctum. They are temporary visitors, bright streaks of change that grace our skies for a few weeks before swinging back out into the silence. There is a romance to their orbits. They are the long-distance travellers who touch both the fire of the sun and the ice of the void, bridging the gap between the known and the unknown. As these comets travel, they leave behind trails of dusty crumbs, a river of debris tracing their orbit. When the Earth, in its own annual journey, wades through one of these streams of comet dust, we experience a meteor shower. Imagine the Earth as a ship sailing through a cloud of fireflies. The tiny grains of dust, often no larger than a grain of sand, strike our atmosphere at tremendous speeds. The air in front of the grain is compressed and heated until it glows white hot, vaporizing the dust in a flash of brilliance. We call them shooting stars, but they are really the last gasp of ancient ice dust turning into light. Visualize lying on your back in a dark field, the smell of grass in the air, watching the sky. A streak of light dashes across the black, silent and swift, then another, and another. It is a silent rain of light. It is a direct connection between the geology of a distant comet and the air you breathe. It feels like a celebration, a display of fireworks put on by nature to remind us that the space around Earth is not empty, but filled with the traces of other worlds crossing our path. One of the largest objects to ever cross Earth's path did so in the violent infancy of the solar system, an event that gave us our most constant companion. This is the Theia impact, the birth story of the Moon. Visualize the early Earth, molten and young. Out of the darkness comes a protoplanet the size of Mars named Theia. They collide, not in an act of destruction, but of fusion. The impact is a slow-motion splashing of liquid rock. Debris is sprayed out into orbit, a ring of red-hot lava circling the wounded Earth. Over time, gravity, the great healer, gathers this debris together. It coalesces, cooling and hardening into the silver sphere we know today. The Moon is not a stranger. It is a daughter of Earth, made of the same mantle, the same isotopic fingerprint. When you look up at the full moon, you're looking at a piece of our own home that was cast into the sky to become a mirror. It is a testament to the idea that something beautiful and stabilizing can arise from chaos. The Moon now acts as a gravitational anchor, steadying Earth's wobble and creating the rhythm of the tides, a constant, soothing reminder of our shared, violent history that's smoothed into a peaceful orbit. And in the quiet moments when the Moon is merely a crescent, a thin sliver of light, we can see a ghostly phenomenon known as Earthshine. Look closely at the dark portion of the crescent moon. It is not pitch black. It glows with a faint ash-grey luminosity. This is the Da Vinci glow, named after the artist who first explained it. Visualize the geometry. Sunlight hits the Earth, bouncing off our bright white clouds and blue oceans. This reflected light travels to the Moon, illuminates the dark night-side surface, and then reflects back to our eyes. It is a reflection of a reflection. When you see Earth shine, you're seeing the light of your own planet projected onto the screen of the Moon. It is a cosmic mirror selfie. It creates a complete circle of light, sun to Earth, Earth to Moon, Moon to eye. It is a soft, delicate illumination, revealing the features of the lunar mare even in the dark. It brings a feeling of intimacy to the solar system, a play of light and shadow that connects the two worlds in a gentle visual whisper, reminding us that we too are a source of light in the dark sky of another world. From this intimate dance of Earth and Moon, let us drift outward again to the structure that holds all these orbits in place, the plane of the ecliptic. Imagine the solar system not as a chaotic swarm, but as a flat, organized disk, like a vinyl record spinning in space. The planets, the moons and the asteroids all travel roughly along this same flat pathway. Visualize this invisible tabletop stretching out from the sun's waist. It is the dance floor of the planets. When you look at the night sky, you can trace this line. If you can find the Moon, and perhaps Jupiter or Venus, you can draw an imaginary arc connecting them. This is the ecliptic. It is the ancient memory of the spinning disk of dust from which we were all formed. It brings a sense of profound order to the cosmos. We are not tumbling randomly, we are aligned. We are marching in a procession. There is a deep rhythmic harmony to this flatness, a geometrical precision that allows us to predict the motions of our neighbours for thousands of years into the future. It is the steady, level ground of our celestial home, a plane of stability in a three-dimensional void. As we traverse this plane, We are constantly bathed in an invisible river that flows from the stars themselves. This is the cosmic ray background. While the name sounds intense, visualize it as a gentle, subatomic rain. These are high-energy particles, protons and atomic nuclei, that have travelled from exploding stars, active galactic nuclei, and solar flares across the universe. They rain down upon our atmosphere constantly, a silent, invisible drizzle of stardust energy. When they strike the upper air, they shatter into showers of secondary particles that reach the ground. At this very moment, harmless muons are passing through your room, through the roof, even through your body, connecting you physically to the depths of distant stars. It is a reminder that we are not separated from the universe by a glass wall. We are permeable. We are swimming in the effluent of the cosmos. The universe is touching us constantly and gently with the remnants of its most energetic events. It is a feeling of being woven into the fabric of space, pierced by the threads of energy that bind the galaxy together. But light and particles are not the only things that cross the void. Gravity, the silent sculptor, creates invisible pathways and valleys in space known as Lagrange points. Imagine the gravitational pull of the Earth and the pull of the Sun. There are specific spots in space where these two giant forces cancel each other out perfectly, creating a zone of gravitational neutrality. Visualize a calm eddy in a rushing river, a place where a leaf can circle endlessly without being swept downstream. These are the Lagrange points. They are the parking spots of space. We place our telescopes and satellites there, where they can hover with minimal effort, balanced on the pinhead of gravity. It is a concept of perfect equilibrium. In the tug-of-war between giant celestial bodies, nature creates these pockets of peace, these sanctuaries of balance. It is a soothing thought to know that even between the most powerful forces, there are places of rest, stable points where one can simply exist, held in place by the opposing tensions of the world. Sometimes, the alignment of these forces creates a visual spectacle that defies logic, a phenomenon known as gravitational lensing. Imagine a massive cluster of galaxies sitting between us and a distant light source. The gravity of this cluster is so immense that it actually bends the fabric of space itself, acting like a giant glass lens. When we look through this lens, the light from the background stars is warped, magnified, and distorted into arcs and rings. Visualize looking through the bottom of a wine glass at a candle flame. The flame is stretched into a circle of light. This is what gravity does to starlight. It allows us to see objects that are too faint and too far away to be seen on their own. The universe provides its own magnifying glass. It is a beautiful, warping embrace that brings the distant near. It creates Einstein rings, perfect circles of light in the dark void. It reminds us that space is not rigid. It is flexible, curvy, and dynamic, bending to the will of mass, helping us to see further than our eyes were ever meant to reach. Drifting from the bending of light to the shifting of colour, we encounter the redshift. This is the colour of expansion, the colour of a universe that is breathing out. As galaxies move away from us in the expanding cosmos, the light they emit is stretched, its waves pulled longer like a slinky. This stretching shifts the light toward the red end of the spectrum. Visualize the night sky not just as a static painting, but as a receding tide. Almost everything we see is moving away, drifting deeper into the dark. The farther away a galaxy is, the faster it is rushing away, and the redder it appears. It is a sign of the Big Bang's echo, the momentum of creation still pushing outward. There is a melancholy but majestic beauty in this. We are in an expanding bubble of reality. The redshift is the lantern swinging on the back of the train as it departs, a signal of the vast, ever-growing distances that separate the islands of stars. It creates a feeling of endless opening, of a room that keeps getting larger, making space for more silence, more dark, and more dreams. And within this expanding dark, there are clouds that do not glow, but rather block the light. These are the dark nebulae, or absorption nebulae. Think of the Horsehead Nebula, a silhouette of ink-black dust standing against a backdrop of red gas. These are not holes in the sky. They are thick, dense clouds of molecular hydrogen and dust, so opaque that no visible light can pass through them. Visualize a shadow puppet show on a cosmic scale. These dark clouds are the cocoons where future stars are sleeping. They are cold, dense, and quiet. They represent the potential of the unmanifested. While the bright stars shout with energy, the dark nebulae whisper with possibility. They are the reservoirs of the next generation. To look at a patch of absolute blackness in the Milky Way is not to look at nothing. It is to look at the coal sacks, the pregnant pauses in the galactic song. They are the velvet curtains waiting to rise, heavy with the dust of creation, reminding us that darkness is often just a cover for something beautiful that is waiting to be born. And where those dark, velvet curtains of dust are not thick enough to block the light completely, they do something equally mesmerizing. They catch it. From the realm of the silhouette, we drift softly into the realm of the phantom to witness the phenomenon of the reflection nebula. Unlike the fiery red emission nebulas that create their own light, these clouds are cool and quiet. They act as cosmic mirrors, scattering the light of nearby stars through their mists. Visualize a street lamp glowing on a foggy night. The air around the lamp isn't generating light, yet it glows with a soft, diffuse halo. This is the nature of a reflection nebula. Because of the way the microscopic dust grains scatter the light, these clouds almost always appear in shades of ghostly ethereal blue, the same physics that paints our Earth sky during the day. Imagine floating through a vast cavern of this blue mist. It is soft, serene, and hauntingly beautiful, like smoke trapped in a beam of moonlight. The Witchhead Nebula is one such place, a profile of blue fog gazing eternally at the star Rigel. It invites you to rest in a place that is not harsh or burning, but cool and illuminated by a gentle scattered radiance, a celestial twilight that never fades. Deep within these glowing caverns and dark clouds, nature is often carving out structures of immense grandeur, leading us to one of the most iconic landscapes in the galaxy, the Pillars of Creation. Located in the heart of the Eagle Nebula, these are not just clouds, they are stalagmites of gas and dust, towering light years high against the background of space. Visualize 3 giant fingers of dark, dense gas reaching upward. They look like ancient ruins, or the trunks of petrified trees standing on a cosmic horizon. But these pillars are being sculpted by a fierce wind. A cluster of massive newborn stars nearby is blasting them with ultraviolet light. This light is slowly eroding the pillars, stripping away the gas in a process called photoevaporation. It is a slow-motion destruction that reveals the new stars hiding inside. To watch the Pillars of Creation is to witness a standoff between the delicate, dark incubators of life and the searing power of the stars they birthed. It is a scene of majesty and resilience, suggesting that even in the face of eroding winds, the structures of creation stand tall and firm for eons, protecting the seeds of the future within their shadows. Sometimes, however, the nursery is not a grand pillar, but a small, isolated drop of ink known as a Bock globule. These are the hermits of the stellar formation process. Imagine a vast, bright field of stars, a glittering carpet of light, and there, in the middle of the brilliance, sits a small, round, perfect patch of blackness. It looks like a hole punched in the sky, but it is actually a dense, cold cloud, a distinct island of gas. Inside this small, spherical cocoon, a single star, or perhaps a pair of twins, is quietly collapsing into existence. Bock globules are intimate spaces. Unlike the chaotic, crowded nurseries of the great nebulas, these are private rooms. Visualize yourself shrinking down to enter one of these globules. The noise of the universe fades away. The light is blocked out. You are wrapped in a blanket of cold dust, safe and hidden. It is a place of gestation, a cosmic womb where the universe focuses all its attention on the creation of just one or two precious points of light. It speaks to the value of solitude, the idea that sometimes to create something new and brilliant, one must withdraw into the quiet and the dark for a time. As the newborn star inside the globule or the pillar begins to wake up, it does not do so quietly. It announces its arrival with a scream of energy, creating a phenomenon known as a Herbig-Haro object. Before a star settles down to a stable life of burning hydrogen, it is violent and rotational. As it spins, it flings material out from its poles at incredible speeds, jets of gas travelling at hundreds of miles per second. Visualize a baby star hidden in a cloud, shooting two thin, straight beams of fire in opposite directions, like the laser beams of a lighthouse. These jets punch through the surrounding nebula, slamming into the cold gas further out. Where they hit, they create glowing shock waves, intricate knots of neon pink, green, and deep red. These are the Herbig-Haro objects, the bow shocks of creation. They look like double-bladed lightsabers or knots on a string, marking the axis of the new star. It is a display of raw, youthful power, a reminder that birth in the cosmos is an energetic, dynamic event. The universe is not static. It is punctuated by these moments of breakthrough, where new energy pierces through the old stagnation to make its mark on the surroundings. This phase of violent youth is characteristic of a specific class of object called the T-Tauri star. These are the adolescents of the stellar family. They have emerged from their cocoons, visible now to the galaxy, but they have not yet settled into the calm, steady rhythm of the main sequence. They are variable, unpredictable, and prone to tantrums. A T-Tauri star is still contracting, still pulling itself together under gravity. Imagine a star that is brighter and larger than our sun, but cooler and wilder. It has colossal star spots covering half its surface and powerful winds that blow away the remaining wisps of its birth cloud. This T-Tauri wind is the housekeeping phase of the solar system. It clears the air. Visualize a strong, steady breeze pushing the dust and gas out of the neighbourhood, polishing the space around the star until it is transparent and clear. It is a necessary turbulence. It teaches us that before stability can be achieved, there is often a period of clearing, a time of fluctuation where the environment is swept clean to make room for the planets that are to come. And speaking of planets, swirling around the waste of these young T-Tauri stars, we find the birthplace of worlds, the protoplanetary disk. When a cloud collapses to form a star, not all the material falls into the centre. Some of it spins out into a flat, rotating pancake of dust and gas. Visualize a giant glowing frisbee spinning around the central amber light of the young star. This disk is a chaotic, beautiful mess of potential. It is made of the same stardust we spoke of earlier: silicates, carbon, ices, and metals. In this swirling carousel, the materials are sorted. Close to the star, it is hot, and only rocks and metals can survive. Further out, it is cool, and gases can freeze. It is a potter's wheel on a cosmic scale. Over millions of years, the grains in this disk will bump into each other, sticking together, growing from dust to pebbles, from pebbles to boulders, and from boulders to worlds. To look at a protoplanetary disk is to look at a solar system in blueprint form, a vast flat ring of opportunity where the architecture of the future is being drafted in spirals of dust. Within this spinning disk, there is a critical, invisible boundary that dictates the destiny of the worlds being born. This is the frost line, or the snow line. Imagine moving away from the warmth of the central fire. You pass through the zone of rock and metal where the Earth would form, and then, at a specific distance, somewhere around the orbit of Jupiter, you cross a threshold. Here, it becomes cold enough for volatile compounds like water, ammonia, and methane to freeze into solid ice. Visualize this line as a glistening circular frontier in the darkness of the disk. Inside the line, the universe is dry and rocky. Outside the line, it is a winter wonderland. Because ice is solid here, there is much more material available to build planets. This is why the gas giants are able to grow so large. They feed on the abundant snows of the outer system. The frost line is the reason our solar system is arranged the way it is. Small, rocky worlds near the hearth and giant, icy behemoths out in the cold. It is a boundary of phase change, a simple temperature gradient that creates the diversity of worlds, reminding us that your distance from the source of warmth determines the very nature of your substance. The process of building these worlds is one of gentle, relentless accumulation, known as accretion. We often think of space impacts as violent explosions, but in the early days of the disk the process is softer. Visualize a dust bunny under a bed. It starts as a few specks of lint, held together by static electricity. It grows slowly, catching more specks, becoming a fluffy, loose ball. This is how the planets began. In the silence of the disk, microscopic grains of dust gently collided and stuck together. Click, click, click. They formed porous, fragile clumps. Then these clumps merged into larger stones. It is a process of patience, there is no rush. Gravity slowly assists, pulling the larger rocks together until they form planetesimals, mini-planets the size of asteroids. These are the building blocks, the Lego bricks of the solar system. Imagine a swarm of millions of these rocks, orbiting together, occasionally bumping and merging, slowly sweeping up the dust of their lane. It is a comforting thought that the Earth, grand and solid as it feels beneath you, was built from the humblest of beginnings, from tiny grains of dust finding each other in the dark and deciding to hold on. As these planetesimals grew, some became so massive that they began to dominate the system, creating the gas giants. But let us look at these giants, Jupiter and Saturn, through a different lens, the lens of the failed star. In composition, Jupiter is almost identical to the Sun. It is a ball of hydrogen and helium, swirling with storms and banded clouds. If Jupiter had been about 80 times more massive, it would have ignited. It would have become a second star and we would live in a binary system. But it stopped short. It remained a planet, yet it radiates heat. Jupiter gives off more heat than it receives from the Sun, glowing in the infrared with the warmth of its own formation, a heat trapped from the gravitational squeeze billions of years ago. Visualize this colossal world, a king planet, acting as a bridge between the stars and the rocks. It protects us. Its immense gravity acts as a shield, deflecting comets and asteroids that might otherwise threaten the inner Earth. It is the elder sibling, the one that didn't quite become a star but used its strength to keep the family safe. There is a deep, resonant power in Jupiter, a low hum of magnetic energy and internal warmth that anchors the planetary family. Just as Jupiter protects the planets, the Sun itself has a protective cycle that influences everything within its reach, known as the solar cycle. We touched on sunspots before, but let us visualize the rhythm itself. The Sun is not a steady, flat tone. It is a breathing, oscillating wave. Every 11 years, the Sun's magnetic field completely flips. North becomes south, south becomes north. This is the heartbeat of the solar system. The Sun wakes up, becomes active, covers itself in spots and flares, and then slowly winds down into a period of quiet and calm, known as the solar minimum. Visualize the Sun sleeping. The surface is blank and golden, the winds are calm, the storms have vanished. Then, slowly, the magnetic knots begin to tie themselves again. It is a lesson in cycles. Nothing in nature maintains peak energy forever. There is activity, and there is rest. There is output, and there is recharge. Even the stars must follow this rhythm of rising and falling, a cosmic respiration that ensures the longevity of the fire. To feel this rhythm is to be in sync with the deepest clock of our local universe, a pendulum swinging slowly, measuring out the decades in magnetic waves. But beyond the magnetic cycles and the wind, the Sun sends us a message in the form of the spectrum, revealing the Fraunhofer lines. When we pass the Sun's light through a prism, we see the beautiful rainbow of colours we expect. But if you look closely, very closely, that rainbow is not perfect. It is slashed with hundreds of thin, dark vertical lines. It looks like a barcode. These dark lines are the missing colours, stolen by the atoms in the sun's atmosphere. Each element, hydrogen, helium, calcium, iron, absorbs a very specific shade of light, leaving a black gap in the rainbow. This is the fingerprint of the star. It is how we know what the universe is made of without ever leaving our planet. Visualize a library of light. Each star sends us its own barcode, a secret message detailing its ingredients. It is a form of cosmic communication, a silent language where the gaps in the light tell the story of the substance. It turns the aesthetic beauty of a rainbow into a book of knowledge, creating a bridge of understanding between the human mind and the atomic heart of a distant sun. Moving from the light of our own sun to the relationships between distant stars, we find that stars often move in loose, travelling groups called stellar associations. Unlike the tight-knit clusters we visited earlier, an association is a drift of stars that share a common origin but have wandered far apart. They are like siblings who have moved to different cities but still carry the family resemblance. The stars of the Big Dipper are part of such a group, the Ursa Major moving group. Most of the bright stars in that plough shape are travelling together through the galaxy at the same speed and in the same direction. Visualize the sky not as random points, but as streams. There are rivers of stars flowing through the solar neighbourhood. We are currently drifting through the outskirts of such a stream. It brings a sense of flow to the static night. We are not just sitting in space, we are swimming in a current, surrounded by a shoal of stars that are moving in unison, a silent, majestic migration that takes millions of years to cross the sky. And within these streams there are stars that challenge our understanding of size and density, known as neutron stars, which we have touched upon, but let us deepen our focus on their most extreme manifestation, the magneta. These are the most magnetic objects in the universe. Visualize a star no bigger than a city, but with a magnetic field 1 trillion times stronger than the Earth's. If a magnetar were to float halfway between Earth and the Moon, its magnetic power would wipe every credit card on the planet and possibly affect the iron in our blood. But from a safe distance, in the realm of dreams, visualize this invisible power. The magnetic field is so strong, it twists the vacuum of space itself. It polarizes the light, bending it into spirals. The surface of the star is under such tension that it occasionally cracks, a starquake. These quakes release flashes of energy that cross the entire universe. A magnetaire is a sleeping dragon, small but possessed of an aura of power that defies logic. It represents the intensity that can be hidden in small packages, the invisible forces that can shape reality without ever touching it physically. But let us retreat from such intensity to the gentle, cooling embers of the cosmos, the carbon stars. These are rare, beautiful rubies in the night sky. As some stars age, they dredge up carbon from their cores to their surfaces. This soot acts like a red filter on a camera lens. It scatters the blue light and lets only the deep, blood-red light escape. To look at a carbon star like R. Leporis, Hin's crimson star, through a telescope is a shocking experience. It does not look like a star. It looks like a drop of glowing blood or a burning coal. It is a deep, rich crimson, darker and more saturated than Mars. Visualize a star that is smoky, dim, and incredibly red. It feels old. It feels like a dying fire in a winter hearth, cozy and final. The stars are the factories of complex chemistry, weaving the carbon atoms that will one day form the basis of life. They are the dusty red grandparents of the galaxy, sitting quietly in the dark, weaving the soot of existence into the light of the future. From the deep, cooling crimson of the carbon stars, we drift toward a stellar phenomenon that represents the opposite extreme of the life cycle, stars that are living with such ferocious intensity that they are literally blowing themselves apart. These are the Wolf-Rayet stars. If the carbon star is a smouldering ember, the Wolf-Rayet is a roaring blowtorch. These are massive stars, 20 times the size of the Sun or more, that have entered a phase of violent, beautiful decay. They burn so hot and so bright that the pressure of their own light pushes their outer layers away into space. Visualize a star that is essentially shedding its skin in a continuous high-speed gale. This is not a gentle breeze like our solar wind. It is a hurricane of stellar material moving at millions of miles per hour. As this wind slams into the surrounding space, it sweeps up everything in its path, creating a hollow, glowing bubble around the star. To look at a Wolf-Rayet star is to look at an artist frantically splashing paint onto a canvas. The nebula created by this wind is chaotic, intricate, and vividly coloured. Filaments of ejected nitrogen and oxygen glowing in electric blues and neon pinks. It is a spectacle of raw power, a star sacrificing its own body to create a masterpiece of gas that will eventually seed the cosmos with the heavy elements needed for new worlds. It is a reminder that sometimes the most beautiful creations come from a release of energy, a letting go of what one used to hold on to. While the Wolf-Rayet stars shed their layers through sheer force, other stars reshape themselves through the dizzying speed of their rotation. We turn our gaze to the B-stars or shell stars. Imagine a star spinning so fast that it is no longer a sphere, but has flattened out into the shape of a squashed pumpkin or a spinning top. The centrifugal force at the equator is so strong that the star is barely holding itself together. Because of this incredible spin, the star naturally flings material off its surface, creating a permanent glowing disk of gas that circles its waist. Visualize a ballerina whose skirt flares out as she pirouettes. This star is wearing a skirt of plasma. This disk is a strange, suspended environment, a decretion disk, where the gas is hot and dense, shining with a specific light that astronomers can detect. To float near a B star would be to witness a world where gravity is almost conquered by motion. The star looks unstable, vibrating with energy, surrounded by this halo of its own making. It teaches us about the balance between holding on and letting go, demonstrating that if you move with enough momentum, you can extend your influence outward, creating a ring of presence that encircles you like a protective charm. In the crowded clusters where stars often live, this proximity can lead to a strange form of rejuvenation, giving rise to the blue stragglers. In a cluster of ancient stars where everyone should be old, red, and tired, astronomers sometimes find bright, hot blue stars that look suspiciously young. They are the anomalies, the ones that refuse to age, but their youth is borrowed. Visualize a pair of stars dancing in a binary system. One is aging, expanding, ready to retire. The other is smaller but hungry. Gradually, the smaller star begins to pull matter from its older companion. It siphons off the hydrogen fuel, feeding on the substance of the other. As it gains mass, it becomes hotter, bluer, and brighter. It literally turns back the clock, resetting its life cycle. While this might sound predatory, in the silent ballet of space, it is simply gravity at work. It is a merger of essences. The old star gives of itself to allow the new one to shine longer. A blue straggler is a testament to the idea that nothing is wasted in the universe. Energy is transferred, mass is moved, and a fire that was dimming can be stoked back into brilliance through the intimacy of a close companion. Sometimes this intimacy goes beyond mere sharing and becomes a total union. We arrive at the concept of contact binaries, specifically the W Ursae Majoris stars. These are two stars that are so close they physically touch. Their atmospheres have merged. Visualize two drops of water just as they connect, held together by surface tension. These stars share a common envelope of gas. If you were to look at them, you wouldn't see two distinct spheres. You would see a glowing peanut shape, or a snowman made of light tumbling through the dark. They rotate together in perfect synchronization, often completing a full turn in less than a day. Because they share an atmosphere, heat flows between them, equalizing their temperatures. They are in thermal contact. It is the ultimate celestial embrace, two hearts beating within a single body of light. There is a profound romance to these objects, locked in a dance so tight that they can never let go, destined to eventually merge completely into a single greater star. They remind us that boundaries are often softer than we think, and that separation can be an illusion dissolved by the attractive forces of nature. These dancing pairs and spinning tops do not drift randomly. They are organised into the grand architecture of the galaxy, specifically the spiral arms. But let us change how we visualise these arms. We often think of the Milky Way as a solid object, like a pinwheel, where the arms are fixed structures. In reality, the spiral arms are density waves. Think of a traffic jam on a highway. The cars slow down, bunch up, and create a dense knot of traffic. Then they speed up and move on. The knot of traffic itself moves down the road, but the individual cars pass through it. This is a spiral arm. It is a cosmic traffic jam. As stars orbit the galaxy, they pass into these density waves, slow down, and bunch together. This compression is what triggers the birth of new stars. The gas clouds are squeezed until they ignite. Visualize the spiral arm not as a rigid limb, but as a rippling wave of pressure moving through the disk. It is a rhythm, a pulse. Stars enter the arm, shine brightly, and eventually drift out the other side. We are currently surfing through the Orion Spur, a minor arm. It is a comforting thought that the structure of our home is created by a gentle, rhythmic bunching of starlight, a wave that travels endlessly around the circle of the galaxy. Within this rotating galaxy, there is a special theoretical zone known as the corrotation circle. The galaxy rotates like a disk, but the spiral arms, the waves, move at a different speed than the individual stars. However, there is a specific distance from the centre where the speed of the stars perfectly matches the speed of the spiral arms. Visualize a surfer catching a wave. If they move too slow, the wave passes them. If they move too fast, they outrun it. But if they match the speed, they can ride the crest forever. A star in the corrotation circle is surfing the galaxy. It stays inside the spiral arm for a very long time. This is a place of stability, but also of danger, because staying in the high-density arm means more exposure to supernovae and radiation. Yet, the image of surfing the cosmos is serene. It represents finding the perfect pace, the sweet spot where your own motion aligns perfectly with the motion of the world around you, allowing you to ride the momentum of the universe with effortless grace. Zooming in from the grand spiral arms to our local neighbourhood, we find ourselves surrounded by a ring of brilliant bright stars known as Gould's Belt. If you look at the night sky, you might notice that many of the brightest stars, those in Orion, Scorpius and Crux, seem to form a great circle that is tilted relative to the Milky Way. This is a local ring of fire. About 30 million years ago, a large cloud of gas in our neighbourhood was disturbed, perhaps by a shock wave, triggering a wave of starbirth that expanded outward like a ripple in a pond. We are inside this ripple. Visualize a hoop of diamonds encircling the solar system. These are young, hot stars, the jewels of our local sky. It creates a sense of community. The stars we see most clearly are our generational peers, born from the same event, travelling together in a loose association. It frames our view of the cosmos, a tilted halo of light that reminds us that we are part of a specific chapter in galactic history, a member of a local family of lights. Inside this ring of stars, we float within a surprisingly empty space called the local bubble. The interstellar medium, the gas and dust between stars, is not uniform. Our sun is currently travelling through a vast cavity, a void within the void, that is shaped like an hourglass and stretches about 300 light-years across. How did this bubble form? Millions of years ago, a series of supernovae exploded nearby. These explosions acted like snowplows, pushing the cold, dense gas outward and clearing out a cavern of hot, thin gas. Visualize a clearing in a dense forest, a meadow where the air is clear and the view is open. We are drifting through this meadow. The walls of the bubble are made of denser cold gas clouds where new stars are forming, but here in the centre, it is quiet and clear. It gives us a pristine view of the universe. We are protected in this pocket of a low density, floating in a safe harbour carved out by the energy of the past, a silent sanctuary in the interstellar terrain. Drifting through this clear local bubble, however, is a subtle wisp of material known as the local interstellar cloud, or the local fluff. Even in the clearest clearing, there is a bit of mist. We have been moving through this cloud for the last few thousand years. It is a wispy, warm collection of hydrogen and helium atoms, incredibly tenuous. If you were to cup your hands in space, you would catch only a few atoms. Visualize a gentle fog, so thin it is invisible to the eye, yet physically present. It flows around the heliosphere of our sun like a stream flowing around a rock. As we travel through it, the magnetic field of our sun deflects most of it, but some filters in. This cloud is a traveller too, drifting from the Scorpio-Centaurus association. It connects us to the winds of other stars. To imagine the local fluff is to realise that space has texture. It is not just empty nothingness, but a landscape of thin clouds and currents. We are sailing through a patch of cosmic weather, a light mist that caresses the edges of our solar system as we sleep. And what does this cosmic weather consist of? If we could open the window of a spaceship and take a deep breath of the interstellar medium, specifically the dust clouds near the centre of the galaxy, we would encounter the scent of space. Astronauts who have returned from spacewalks describe a distinct odour clinging to their suits, a metallic, acrid smell like seared steak, hot metal or welding fumes. But deep in the molecular clouds, the chemistry is even more complex. Astronomers have identified a class of molecules called polycyclic aromatic hydrocarbons, PHs. On Earth, these are found in coal and soot, but in the vast laboratory of space they float freely. In some clouds, like Sagittarius B2, the chemical mix includes ethyl formate. If you could smell this cloud, it would carry the scent of rum and the flavour of raspberries. Visualise the universe not just as a visual spectacle, but as a sensory garden. Giant clouds that smell of sweet fruit and rum, drifting in the silence. Other clouds might smell of almonds, cyanide, or rotten eggs, sulphur. It adds a layer of richness to the dark. The universe is a kitchen of elements, constantly cooking, mixing and combining atoms into molecules that we recognise here on home. It invites you to breathe in the night, to imagine the sweet, metallic, ancient perfume of the stars, a scent that has been distilling in the vacuum for billions of years, waiting for a nose that will likely never smell it, existing simply for the sake of existence. And while that faint raspberried scent of the cosmos lingers in the imagination, reminding us of the subtle chemistry of the deep, we begin to feel a gentle tug, a current that carries not just the scent but the stars themselves. We are drifting now toward a mystery that pulls at the very fabric of our galaxy, a phenomenon known as the Great Attractor. Imagine you are a leaf floating on a wide, calm river. You feel stationary, but the water beneath you is moving, carrying you and everything around you toward a distant destination. Our Milky Way, along with hundreds of thousands of other galaxies, is flowing through space like that leaf. We are being pulled toward a region of space hidden from our view by the dust of our own galactic plane, a region known as the zone of avoidance. We cannot see what lies there with our eyes, but we can feel its gravity. It is a gravitational anomaly of immense power, a concentration of mass equivalent to tens of thousands of galaxies. Visualize a great invisible basin in the fabric of space-time, a valley into which all the surrounding rivers of light are draining. There is a sense of surrender in this motion. We are not fighting the current. We are part of a grand cosmic migration, sliding smoothly through the void at millions of miles per hour toward this enigmatic gathering point. It reminds us that there is a larger order to the universe, a hidden architecture that guides the motion of worlds, a silent summoner calling the galaxies home. As we pull back further to see where this river leads, the scale of the universe expands dramatically, revealing that our galaxy is merely a tiny node in a much larger structure called the Laniakea Supercluster. The name itself is a lullaby, Hawaiian for immeasurable heaven. Visualize a map of a watershed on Earth, where hundreds of tiny streams trickle down mountainsides, merging into creeks, then rivers, all flowing toward the same ocean. Laniakea is a watershed of gravity. It is a structure of feathery strands of light, composed of over 100,000 galaxies, all interconnected and flowing along invisible valleys toward the great attractor. Imagine looking down at this structure from far above. It glows like a neural network, or the delicate veins of a leaf, or the bioluminescent tendrils of a deep-sea creature. We live on one of the outer fringes of these great tendrils, a quiet suburb in the immeasurable heaven. To visualize Laniakea is to understand that we are part of a continent of galaxies, a vast flowing archipelago of light that spans 500 million light years. It offers a feeling of profound connection, knowing that our Milky Way is holding hands with thousands of other galaxies, bound together by the gentle, relentless slope of gravity into one magnificent glowing family. Zooming out even further until the superclusters themselves look like tiny knots, we witness the skeleton of the cosmos, the cosmic web. This is the largest pattern in nature. Visualize a dark room filled with a three-dimensional spiderweb made of silk. The silk threads are not solid. They are filaments of dark matter and gas, stretching across the abyss for billions of light years. And clinging to these silken threads, like morning dew on a spiderweb, are the galaxies. The universe is not a random scattering of stars. It is a lattice. It is built. Between the threads lie vast, empty caverns of darkness, and along the threads, the light congregates. Imagine travelling along one of these filaments. It is a highway of light, a bridge connecting the great cities of the universe. To see the cosmic web is to see the texture of reality itself. It looks organic, like the structure of a sponge or the neurons in a brain. It suggests that the universe is a single, cohesive entity, a grand design where matter is distributed with delicate precision, weaving a tapestry of light against the backdrop of the eternal dark. It is a comforting thought to be caught in this web, held securely in the intricate netting of the cosmos. But where there is a web, there must be spaces between the threads. Drifting away from the filaments, we enter the regions of profound silence known as the cosmic voids. Specifically, let us float into the Bhuta's void, often called the Great Nothing. Imagine a region of space so vast that if you were placed in its centre, you would see nothing but absolute blackness. It is a sphere of emptiness nearly 300 million light-years across. If the Milky Way were in the centre of the Bhuta's void, we would not have known other galaxies existed until the invention of powerful telescopes in the 1960s. The neighbours are simply too far away. Visualize floating in this deep, dark ocean. It is the quietest place in the universe. There are no nearby stars to dazzle the eye, no nebulae to paint the sky. There is only the deep velvet peace of the void. It is a sanctuary of isolation. In a universe that is often crowded and chaotic, the voids represent the breath, the pause, the open space that allows the structure to exist. It is a place of rest, where gravity's pull is faint and distant, and one can float in the perfect weightless suspension of the deep dark. Yet, even in these lonely voids, there are wanderers. This brings us to the intergalactic stars. Not all stars live in the warm embrace of a galaxy. Some have been flung out, exiled by the gravitational tussle of merging galaxies or the slingshot of a black hole. These are the rogue stars drifting alone in the immense distances between the islands of light. Imagine standing on the surface of a planet orbiting such a star. Your sun would rise and set, bringing a warm, familiar day. But when night fell, the sky would be startlingly different. There would be no Milky Way, no field of stars, only a pitch-black canopy dotted with a few faint fuzzy smudges which are distant galaxies. It would be a sky of absolute solitude. These stars are the hermits of the cosmos, carrying their own light into the wilderness. They remind us of the resilience of fire. Even cut off from the herd, separated from the structure of the galaxy, a star continues to burn, to shine, to be a centre of gravity and warmth in the middle of nowhere. It is a beacon of independence, a solitary lantern drifting through the endless night. From the smallest, loneliest stars, we turn our imagination to the sheer scale of the titans, the hypergiants. Let us visualize the star UY Scuti. To understand this star, we must abandon our earthly sense of scale entirely. If you were to replace our sun with UY Scuti, its surface would not just touch the Earth, it would extend out past Mars, past the asteroid belt and swallow Jupiter. Imagine flying an airplane along the equator of this star. To circumnavigate our sun would take months. To circumnavigate UY Scuti would take over 1,000 years. It is a ball of red fire so vast that it creates its own horizon, a wall of plasma that seems flat because the curve is so subtle. It is not dense and hard. It is a red vacuum, a tenuous puffing cloud of heat that barely holds itself together. To float near it is to face a wall of red light that fills your entire vision, up, down, left, and right. It glows with a deep, ruby incandescence. It humbles us, shrinking our concerns to microscopic points, reminding us that the universe creates on scales that our minds can barely contain, filled with monsters of light that burn with a majesty beyond words. While UY Scuti impresses us with size, other stars impress us with their age. We drift now to the Methuselah star, HD Justenstiast 283. This star is a time traveller. It is located right here in our own galaxy, drifting quickly through our neighbourhood, but it is a visitor from a different era. Analysis of its light reveals that it is incredibly poor in metals. It has almost no iron. This means it was born before the galaxy was filled with the dust of dead stars. It is estimated to be around 14 billion years old, almost as old as the universe itself. Visualize this star as an ancient grandfather, sitting quietly on a porch, watching the younger stars like our sun run and play. It has seen everything. It witnessed the formation of the Milky Way's spiral arms. It saw the birth of Earth. It has burned steadily and thriftily for eons. Its light is a pale yellow-orange, a flicker of ancient wisdom. To look at the Methuselah star is to look directly into the deep past, to make eye contact with the beginning of time. It is a symbol of endurance, proving that some lights do not fade, but keep watch over the ages, carrying the memory of the dawn. Some stars, however, are not content to simply sit and watch. They race through the cosmos with such speed that they transform their environment. Let us visualize the star Mira, the wonderful. For centuries, astronomers watched Mira pulse, brightening and dimming, but only recently did we see its secret. Mira is moving through space at a blistering speed, 290,000 miles per hour. Because it is moving so fast and shedding its outer layers like a dying red giant, it has created a tail. Visualize a comet, but on a stellar scale. Mira is leaving a wake of glowing blue gas behind it that stretches for 13 light years. It looks like a seed swimming upstream, or a cosmic tadpole. This tail is made of carbon, oxygen, and other elements. The star is literally seeding the galaxy as it flies, dragging a plough of stardust behind it. It is a beautiful image of motion and creation. A star that is not just a point of light, but a paintbrush, drawing a long glowing line across the canvas of the sky, leaving a trail of ingredients for future worlds in its wake. This shedding of material can sometimes take on shapes of perfect eerie symmetry, leading us to the Homunculus Nebula, the shroud of the doomed star Eta Carinae. This is a binary system teetering on the brink of a supernova explosion. In the 1840s it erupted in a great eruption, temporarily becoming the second brightest star in the sky, but it survived. The explosion created a nebula shape unlike any other. Visualize two bulbous lobes of gas, expanding outward from the star in opposite directions, like a giant glowing hourglass or a celestial peanut. The star sits hidden in the pinched waist between the two lobes. The gas is expanding at over 1,000,000 miles per hour. glowing with a soft, warm orange light. It looks like an explosion frozen in time, a slow-motion snapshot of a catastrophe. It is a reminder of the tension held within massive stars, the delicate balance between gravity holding in and radiation pushing out. The homunculus is a beautiful scar, a testament to a near-death experience that resulted in a sculpture of gas that has captivated watchers for nearly 2 centuries. Finally, we look away from the specific stars and back to the geometry of our own sky, to realise that the forever we see is actually shifting. This is the precession of the equinoxes. We rely on Polaris, the North Star, as our fixed point. But the Earth is like a spinning top that is slowly wobbling. A single wobble takes 26,000 years. This means that Polaris will not always be our guide. Visualize the axis of the Earth slowly tracing a circle in the northern sky. Thousands of years ago, when the pyramids were being built, the North Star was a faint star named Thuban in the dragon constellation Draco. And in 12,000 years, the brilliant blue-white star Vega will take the throne as our North Star. The sky is a clock with a very long hand. The constellations are drifting. The pole is shifting. It reminds us that permanent is just a relative term. Even the steadfast North Star is just passing through the position of honour. It brings a sense of fluidity to time, a knowledge that the sky our descendants will look up to will be different from our own, a slow, majestic changing of the guard that marks the deep rhythm of the planetary dance. This slow, majestic shifting of the celestial pole reminds us that our perspective is never truly fixed. It is always a matter of angles and time. This leads us deeper into the geometry of the night, to a concept known as stellar parallax. To understand this, imagine holding your finger up in front of your face. Close one eye, then the other. Your finger seems to jump back and forth against the background of the wall. This is not because your finger has moved, but because you are viewing it from 2 slightly different vantage points. The Earth does the same thing on a grand scale. As we orbit the Sun, our position in space shifts by millions of miles from January to July. When we look at the nearby stars from these opposite sides of our orbit, they appear to wiggle ever so slightly against the backdrop of the much more distant stars. Visualize this subtle, silent shifting. It transforms the night sky from a flat wallpaper into a 3-dimensional forest. The stars are not painted on a dome. They are trees of light standing at vastly different depths. When you look up, you're looking into a deep, infinite well. Parallax is the depth perception of the cosmos, the triangulation of the void. It gives volume to the darkness, allowing your mind to step into the sky and walk among the stars, knowing that some are close enough to be neighbours, while others as distant beacons on the far side of the unimaginable. Floating through this 3-dimensional forest, our eyes naturally seek patterns, anchoring us to the seasons. High overhead in the warm months of the Northern Hemisphere, 3 brilliant stars form a distinct giant shape, the Summer Triangle. This is not a constellation itself, but an asterism, a pattern borrowed from 3 different constellations. Visualize connecting the dots between the bright blue-white star Vega, the distant luminous Deneb, and the fast-spinning Altair. Together, they form a massive wedge, a celestial arrowhead pointing the way down the river of the Milky Way. Imagine lying back on warm grass, the sound of crickets rhythmically pulsing in the air, looking up at this grand triangle. It dominates the zenith. Vega, the sapphire of the lyre, burns with a fierce, crisp brightness. Deneb, the tail of the swan, is far dimmer to the eye but is actually a supergiant lighthouse thousands of light years away. Altair, the eagle, completes the trio. This triangle is a seasonal clock. When it rises high, the nights are warm and short. When it begins to sink in the west, the leaves turn and the air chills. It is a comforting, stable structure, a roof beam for the summer night, holding up the sky while the galaxy flows silently through its centre. Drifting closer to the centre of this great triangle, within the constellation of Cygnus the Swan, we find one of the most exquisite jewels of the night sky, the binary star Albireo. To the naked eye, it appears as a single modest point of light, marking the beak of the swan. But if you were to look through a telescope, or simply float closer in your dream body, you would see it split into two distinct, breathtaking gems. Alboreo is the gold and blue standard of the cosmos. The primary star shines with a rich, warm, golden amber hue, like a drop of honey or a burning topaz. Its companion sitting close by is a brilliant, striking sapphire blue. The contrast is startling. In a universe where most stars look white or slightly yellow, Alboreo is a splash of artistic colour. Visualise these two stars drifting together, a pair of complementary colours painted on the black canvas. They are a double star in the truest aesthetic sense, creating a visual harmony that feels designed. They remind us that the universe is not monochrome. It is capable of subtle, beautiful artistry, placing the warm glow of gold next to the cool calm of blue, a celestial jewellery box left open for us to admire. While Alboreo dazzles with colour, other regions of the sky captivate us with the absence of it. Drifting into the southern skies near the famous Southern Cross lies a patch of darkness so profound it has earned the name the Coalsack Nebula. This is not a void, it is a silhouette. It is a dense cloud of cold dust, much like the dark nebulae we spoke of before, but this one is prominent, appearing as a dark, inky thumbprint against the bright star-studded band of the Milky Way. For the indigenous astronomers of the Southern Hemisphere, this darkness was not empty space, but a physical object, the head of a great emu in the sky. Visualize a cloud so thick that it blocks the starlight from behind it, creating a hole in the heavens. It looks like a drop of black ink in a river of milk. There is a deep, quiet mystery to the Coalsack. It represents the unknown, the hidden potential. It is a curtain drawn across the window, suggesting that what we cannot see is just as important as what we can. It invites the eye to rest. In a sky overwhelmed with billions of points of light, the Coalsack offers a place of repose, a velvety patch of nothingness where the mind can settle into the cool, dark peace of the unmanifested. Just next to this patch of profound darkness sits a cluster of stars that offers the ultimate contrast, a collection so colourful it is known as the Jewel Box Cluster, Kappa Crucis. If Alboreo is a two-tone ring, the Jewel Box is a pirate's chest spilled onto black velvet. Contained within a small area, barely visible to the naked eye but exploding with detail upon closer inspection, is a tight gathering of over 100 stars. Most of them are bright, young blue supergiants, burning with a fierce, icy intensity. But right in the centre sits a solitary, brilliant red supergiant. The contrast is striking, like a single ruby dropped into a pile of diamonds and sapphires. Early observers described it as a piece of fancy traffic light jewellery. Visualise the sparkle of this cluster. It glitters. The atmosphere makes the different colours dance and twinkle, creating a kaleidoscope effect. It is a celebration of stellar diversity huddled together in the dark. It reminds us of the richness of the galaxy, that in one small pocket of space, nature can gather together such a variety of hues and intensities, creating a hidden treasure trove that waits patiently in the southern sky to be discovered. Leaving the intimate gathering of the Jewel Box, we expand our view to encompass the largest, most magnificent city of stars in our galaxy's orbit, Omega Centauri. This is not just a cluster, it is a metropolis. While most globular clusters contain hundreds of thousands of stars, Omega Centauri contains 10 million. It is so massive and bright that it looks like a fuzzy star to the naked eye, but up close, it is a swarming hive of light. Imagine floating toward this giant sphere. As you approach, the individual stars begin to resolve, but the centre remains a solid, blinding wall of white brilliance. The stars here are packed so tightly that if you lived on a planet in the core, the nearest star would be only a fraction of a light year away. The night sky would be a blazing canopy of thousands of suns, banishing all darkness. Astronomers believe Omega Centauri might be the ancient core of a dwarf galaxy that was long ago swallowed by the Milky Way, stripped of its outer stars, leaving only this dense, majestic heart. It is a survivor. It is a ball of ancient light, humming with the energy of millions of siblings, rotating slowly in the halo of our galaxy, a monument to the cannibalistic history of the cosmos. As we look back at the Milky Way from the halo, we notice that the band of light is not unbroken. It is split lengthwise by a dark, jagged lane known as the Great Rift. This is a colossal complex of dust clouds that obscures the centre of the galaxy, appearing to divide the river of light into two streams. It runs from the constellation Cygnus down to Sagittarius. Visualize a dark canyon flowing through a river of fire. To the ancients, this rift was a river of the underworld, or a dark path for spirits. It adds texture and drama to the sky. Without the Great Rift, the Milky Way would just be a glowing smudge. With it, it becomes a landscape. It has geography. Visualize the depth of these dust clouds, light years thick, floating between us and the galactic core. They are the curtains of the stage. They create a sense of layering, reminding us that we are looking through miles of weather to see the stars beyond. The rift is the silence within the sound, the shadow within the light, creating a balance that makes the Milky Way look like a rugged organic entity rather than a perfect artificial geometry. Within this organic landscape, colours usually follow the rules of physics. Red is cool, blue is hot. But there is a star that has whispered a different story to observers for millennia, Zubeneshmali, the brightest star in the constellation Libra. It is often described as the only naked-eye green star. In reality, stars cannot truly be green because of how they emit light. They pass through white on their way from red to blue. However, the human eye and mind are powerful filters. Many observers, both ancient and modern, look at Zubeneshmali and see a pale, ghostly emerald tint. Visualize this phantom colour. Imagine a star glowing with the soft, verdant hue of a distant lantern in a forest. Whether it is a trick of the atmosphere, a contrast with nearby stars, or a property of the star we do not yet understand, the experience of the green star is real to the dreamer. It represents the mystery of perception. It suggests that the universe is not just what is physically there, but what we perceive it to be. It invites you to look closer, to test your own senses against the dark, and to find the rare, elusive shades of magic that might be hiding among the familiar white lights. The colour of a star tells us its temperature, but sometimes the light carries a heavy burden of history. This leads us to the concept of the garnet star, Muchepe. Located at the edge of the nebula IC 1396, this is one of the largest and reddest stars visible to the naked eye. If you were to place it in our solar system, it would extend to the orbit of Saturn. But it is the colour that captivates. It is not just orange, it is a deep, bloody, rich crimson. William Herschel, the great astronomer, described it as looking like a drop of blood or a garnet gemstone. Visualise this deep, simmering ember. It is a star in the very late autumn of its life, cool and puffy, surrounded by shells of its own ejected dust which filter the light, deepening the red hue. To gaze at the garnet star is to feel a sense of warmth in the cold vacuum. It feels cosy, like a dying fire in a hearth. It is a cool supergiant, burning its fuel with a slow, smoky grandeur. It stands as a lighthouse of the deep infrared, a beacon of old age and endurance, glowing with the sombre, beautiful light of a long life well lived. Finally, we look past the individual stars, past the dust lanes and past the clusters, to the very background of the canvas itself. If you could turn up the sensitivity of your eyes to see microwaves, the entire sky would not be dark. It would be glowing with a faint uniform static. This is the cosmic microwave background, CMB. It is the oldest light in the universe, the afterglow of the Big Bang itself. After the universe was born, it was a hot, opaque fog. When it finally cooled enough for atoms to form, the light broke free, travelling through space for 13.8 billion years. Over that vast epoch, the expansion of space has stretched that light from blinding white heat into cool, invisible microwaves. Visualize this background energy. It is everywhere, in the space between stars, in the space between galaxies, even in the space between your fingers. It is the ambient temperature of the cosmos, a steady 2.7 degrees above absolute zero. Think of it as the hum of the universe, the static on an old analog television set. Indeed, a fraction of that static was the CMB. It is a blanket of fossil light that wraps around everything. It is a comforting thought. There is no true emptiness. The universe is filled with this relic of creation, a soft, invisible glow that connects every point in space and time to the moment of origin. You are bathed in the light of the beginning, a silent, ancient energy that holds the memory of the first moment, filling the silence of your sleep with the echo of creation. From that ancient, static hum of the cosmic microwave background, which wraps the universe in a blanket of fossil light, we turn our inner eye to the invisible scaffolding that lies beneath it. We often think of the stars as the main characters of the cosmos, but in truth, they are merely the glittering ornaments hanging on a much larger unseen structure. This is the presence of dark matter. Imagine walking through a forest at night. You can see the fireflies flickering, but you cannot see the trees. Yet, you know the trees are there. You feel the wind moving around them. You sense the solidity of the forest holding the fireflies in their lanes. Dark matter is that invisible forest. It is 5 times more abundant than the normal matter that makes up the stars, the planets, and your body. It does not glow, it does not reflect, and it does not cast a shadow. It is a ghost substance, passing through the earth and through you at this very moment without a whisper. But we know it is there because of its embrace. Its gravity creates a deep, heavy cradle that holds the galaxies together. Without dark matter, the Milky Way would spin itself apart. The stars would be flung out into the void like loose pearls from a broken necklace. Visualize this invisible substance not as a void, but as a gelatinous, heavy ocean, transparent and vast, in which the galaxies are suspended like glowing jellyfish. It is the silent, strong hand that cups the light, the unseen protector that ensures the structure of the universe remains intact while you sleep. While dark matter pulls everything together in a gravitational hug, there is another, more mysterious force that is slowly, gently pushing everything apart. We drift now to the concept of dark energy. If dark matter is the gravity that anchors us, dark energy is the breath that expands the chest of the universe. For a long time, we believed the universe was slowing down, that gravity would eventually win. But we were wrong. The universe is accelerating. It is growing larger, faster every second. Visualize a ball of dough rising in a warm bowl. As the dough expands, the raisins inside it move further and further apart. They are not moving through the dough. The dough itself is creating more space between them. This is what dark energy does to the fabric of the cosmos. It is creating more space. It is a smooth, relentless, and silent stretching. There is a profound peace in this expansion. It suggests that the universe is not a static box, but a living, growing entity, exhaling into the infinite. This force creates a sense of endless openness, a promise that there will always be room, always be more horizon. It creates a solitude for the galaxies, pushing them gently away from one another, allowing each island of stars to have its own vast, private ocean of vacuum, undisturbed and sovereign in the deep night. The interaction of these colossal forces, the pulling of matter and the stretching of space, creates the fabric of reality itself, a fabric that can be rung like a bell. This brings us to the phenomenon of gravitational waves. Einstein dreamed of them a century ago, but only recently have we felt them. Imagine the universe as a calm, flat sheet of water, perfectly still. Now, visualize 2 black holes, heavy and dark, spiraling around each other in the center of the lake. As they dance closer and closer, spinning faster and faster, they eventually collide. This collision does not make a sound in the air, for there is no air in space. Instead, it shudders the water itself. Ripples travel outward from the crash site, moving at the speed of light. These are gravitational waves. They are ripples in the very texture of space-time. When a gravitational wave passes through the Earth, it stretches and squeezes the planet, and you, by a fraction of the width of an atom. You physically stretch and compress as the echo of a distant cosmic event washes over you. It is the heartbeat of a binary merger, a rhythmic pulse sent out across the eons. To visualize this is to realize that space is not empty nothingness. It is a medium, a substance that can tremble, quake, and carry the silent vibrations of the most powerful events in history directly to your bedside. And what happens when these ripples originate not from black holes, but from the collision of two neutron stars? We arrive at one of the most precious events in the cosmos, the kilonova. This is the cosmic forge. For eons, alchemists tried to turn lead into gold. The universe does this in the blink of an eye. When two ultra-dense neutron stars crash into each other, the heat and pressure are so intense that they instantly forge the heaviest elements in the periodic table. Visualize a flash of light that is not just bright, but rich. In that explosion, a cloud of pure gold, platinum and silver is blasted out into the galaxy. The gold in the ring on your finger, the platinum in a watch, the uranium in the ground, all of it was born in this violent, beautiful moment. It is literally stardust, but of the rarest kind. Imagine a mist of molten gold expanding into the cold vacuum, cooling and solidifying into nuggets and dust that eventually find their way into the swirling clouds that form planets. It connects the value we place on these metals to the grandest cycles of the stars. You're wearing the debris of a dead star's collision. It adds a weight and a history to the jewellery of Earth, reminding us that beauty and rarity are forged in the fires of transformation. From the heavy golden aftermath of a crash, we look to the delicate artistic aftermath of a lone star's death. We drift to the constellation of Cygnus to witness the Veil Nebula. This is a supernova remnant, but it does not look like an explosion. It looks like lace. A massive star detonated here thousands of years ago, and the shock wave has been travelling outward, sweeping up the interstellar dust into thin glowing sheets. Visualize a scarf made of the finest silk, dropped from a high window, fluttering and twisting in the wind as it falls. The nebula is composed of these twisted filaments of gas, glowing in soft shades of magenta, teal and violet. It is incredibly detailed. The threads are so fine they look like scratches on a photographic plate, or the intricate webbing of a spider. It is also known as the witch's broom, sweeping the dust of the galaxy. There is a softness to the Veil Nebula that defies the violence of its origin. It floats in the dark like a ghost, a diaphanous curtain that reminds us that even destruction can leave behind a legacy of fragile, haunting beauty, suspended in the stillness of the summer sky. If the veil is a curtain, then our next destination is an eye looking back at us. We travel to the constellation Aquarius to find the Helix Nebula. This is one of the closest planetary nebulae to Earth, and its geometry is perfectly aligned with our view. We are looking straight down the barrel of a cylinder of gas, making it appear as a perfect ring. It is often called the Eye of God. Visualize a giant cosmic eye light years across. The pupil is the white dwarf star sitting in the centre, hot and piercing. The iris is a ring of glowing gases, blue in the centre, transitioning to a deep rusty red on the outer edges. The eyelashes are cometary knots, clumps of gas that have been blasted by the stellar wind, trailing tails behind them. Despite the dramatic name, the gaze of the helix is not judging. It is unblinking and serene. It is the final expression of a dying star, a widening circle of breath that will eventually dissipate into the night. It invites a feeling of being seen, of a reciprocal gaze between the dreamer and the deep watching universe, a silent acknowledgement of presence. From the solitary eye of the helix, we move to the vibrant, beating heart of a stellar nursery, the trapezium cluster, Deep within the Great Orion Nebula, which looks like a fuzzy sword hanging from the hunter's belt, lies a tight grouping of 4 massive stars. They are the engine of the nebula. Visualize a cavern of dark clouds, illuminated from within by a chandelier of 4 brilliant blue-white bulbs. These stars are young, arrogant, and fiercely hot. Their ultraviolet light acts like a chisel carving out a bowl in the dusty cloud, allowing us to see inside. The light reflects off the chaotic walls of the nebula, creating a landscape of glowing mountains and valleys in shades of electric green and dusky rose. The trapezium stars are the jewels in the setting. They are huddled together, their combined energy driving the winds that shape the entire region. To look at them is to look at the spark of life, the energetic centre that illuminates the surrounding darkness, proving that a small group of brilliant lights can push back the shadows and create a spectacle of colour for light years around. Encircling this entire region of Orion, hugging the hunter and his nebula, is a faint, massive structure known as Barnard's Loop. This is an emission nebula that forms a giant red semicircle, creating a cradle for the constellation. It is too faint to be seen with the naked eye, but in long exposure photographs it reveals itself as a glowing arc of hydrogen. Visualize a protective arm draped around the shoulders of the hunter. It is a wreath of soft red light, likely the remnant of a series of supernovae that exploded millions of years ago, puffing a bubble into the interstellar medium. The loop gives the constellation a sense of containment. It creates a boundary, a designated zone of activity. It feels like a cosmic embrace, a warm red glow that encircles the fierce blue stars of Orion, softening their intensity. It suggests that even the warriors of the sky are held within a larger, softer curvature of light, a background glow that ties the disparate stars into a single, unified story. Leaving the hot, glowing loops and blue giants, we descend the temperature scale to find an object that challenges our very definition of a star. We have visited the red dwarfs and the brown dwarfs, but colder still are the white dwarfs. These are the room temperature stars. Imagine a star that you could touch without burning your hand. Some of these objects have surface temperatures of only 80 degrees Fahrenheit, no hotter than a cup of coffee or a warm summer day. They are dark, emitting almost no visible light, glowing only faintly in the infrared. Visualize a sphere of swirling gas, purple and black, bruising the darkness. It would not shine, it would loom. If you were close to it, you would feel a gentle warmth radiating from it, like the heat from a radiator in a dark room. These are the hidden citizens of the galaxy, blurring the line between star and planet. They are cozy stars. They represent the cooling down of the universe, the quiet, low-energy states that exist in the shadows. They remind us that power does not always mean fire. Sometimes it is just a gentle, persistent warmth in the cold. Drifting from the warmth of the dark stars, we find ourselves contemplating the overarching stillness of the cosmos, the concept often called the Great Silence. We know the galaxy is old. We know it is filled with planets, with water, with organic molecules. And yet, when we turn our radio telescopes to the sky, we hear only the static of the stars and the hiss of the hydrogen clouds. There is no chaotic chatter of other civilizations, no beacons, no noise. While some find this lonely, let us visualize it as a sanctuary. Imagine a library at night, vast and filled with knowledge, but utterly quiet. The silence is not an emptiness, it is a peace. It is the privacy of the cosmos. The distances between the stars are so great that every world is insulated, wrapped in a blanket of light years that muffles all sound. It means that Earth is a secluded garden. The Great Silence allows us to dream without interruption. It turns the night sky from a busy highway into a calm, reflective mirror. It suggests that the default state of the universe is tranquility, a deep, resonant hush that allows every star to burn with its own unique light, unbothered and sovereign, sharing the dark only with the quiet watcher who lies safe in bed. Within this silence, however, there are beacons that pulse with the precision of a clock, anchoring us in time. We revisit the pulsars, but specifically the millisecond pulsars. These are the recycled stars, old neutron stars that have been spun up by a companion until they rotate hundreds of times per second. Visualize a lighthouse beam sweeping over you, but it is spinning so fast it creates a tone, a hum, zzzzt. These stars are the most accurate clocks in the universe, more stable than atomic clocks on Earth. They are the GPS satellites of the galaxy. If you were a traveller navigating the deep void, you would use these rapid pulses to find your coordinates. They form a grid of sound and light. There is a comfort in this mechanical precision. In a universe of chaotic explosions and drifting clouds, these spinning tops maintain a perfect rhythm, beat after beat, century after century. They are the metronomes of eternity, keeping the time of the cosmos, ensuring that even in the drift of sleep, there is a steady underlying order that holds the moment together. Drifting away from the hum of the pulsars, we find ourselves looking at the space between the stars, which we assume is empty. But floating there, untethered to any sun, are the rogue planets, specifically a class known as free-floating evaporating planets. These are worlds that are not only lost but are slowly dissolving into the ether. Visualize a planet made of ice and gas, drifting alone. Without the gravity of a star to hold it together, and bombarded by the cosmic rays we spoke of, it trails a long, comet-like tail of its own atmosphere. It is a planet turning into a cloud. It is a surrender. The planet is letting go of its form, expanding into the greater body of the universe. It is a slow, graceful dispersal. It teaches us about the fluidity of identity in the cosmos. Nothing is solid forever. Even worlds can become breath, fading softly into the background, their substance becoming the seeds for future stars, a gentle recycling that happens in the quiet lanes between the galaxies. Sometimes the universe arranges these drifting materials into shapes that mimic our own biology, leading us to the Heart Nebula. Located in the constellation Cassiopeia, this is a vast cloud of glowing red hydrogen gas and dark dust lanes that form a nearly perfect shape of a human heart. Visualize this red, anatomical symbol glowing in the deep winter sky. It is not small, it is hundreds of light years across, powered by a cluster of young stars in its centre known as Melot 15. These stars are the pulse of the heart, pushing the gas outward to sculpt the ventricles and valves of the cloud. It is a romantic coincidence of physics. To look at the Heart Nebula is to feel that the universe is in some abstract way alive. It pulses with energy, it circulates matter, it has a heart. It is a warm red lantern in the dark, a celestial valentine that suggests love and vitality are not just human concepts, but are woven into the very shapes of the interstellar clouds. Just as the nebula mimics the heart, other stars mimic the most precious stones of the Earth. We drift to the concept of the diamond planets, such as 55 Cancri E. This is a super-Earth that orbits extremely close to its star, but unlike our world of silicate rocks, this world is rich in carbon. Because of the intense heat and the crushing pressure of its own gravity, scientists believe the interior of this planet is composed largely of diamond. Visualize a world where the bedrock is crystal, the mountains are made of jagged diamonds, the tectonic plates are sheets of diamond. It is a planet of hard, cold brilliance, likely glittering and translucent under the glare of its nearby sun. It reframes our idea of value. On Earth, a diamond is rare and coveted. Here it is the dirt underfoot, it is the mountain range. It reminds us that the universe is vast enough to make the rare common, creating entire worlds out of the substances we consider most precious, floating like jewellery in the dark. From the brilliance of diamond worlds, we retreat to the dusty, unseen edges of our own home, to the scattered disk beyond Pluto where we find objects like Sedna. Sedna is a dwarf planet that lives in the absolute hinterlands of the solar system. It takes 11,400 years to complete one orbit. Visualize a world that is painted a deep rusty red, covered in tholins, organic compounds darkened by eons of starlight. It is incredibly cold, sitting in a permanent dim twilight. The sun from Sedna looks like just another bright star, a pinprick that offers no heat. Sedna is the ultimate introvert. It spends most of its life in the dark, far from the bustling family of the inner planets. It travels into the deep, empty space between the sun and the Oort cloud, a region of profound loneliness. But in that loneliness, there is freedom. Sedna answers to no one, disturbed by no other gravity, tracing a long, slow, silent ellipse through the quietest parts of the night. It is the guardian of the outer boundary, the silent watcher at the gate. As we drift past Sedna, leaving the solar system behind, we encounter the concept of the galactic habitable zone. Just as a planet must be the right distance from a star to have water, a star must be the right distance from the center of the galaxy to be safe for life. If you're too close to the core, the radiation is too high and the stars are too crowded. If you're too far out in the rim, there aren't enough heavy metals to build planets. We live in the suburbs, the Goldilocks zone of the Milky Way. Visualize a ring of life, a torus of safe harbour within the spinning disk. It is a circle of sanctuary. It implies that our location is special, not by accident, but by necessity. We are nestled in the quiet, fertile band of the galaxy, protected from the chaotic storms of the core and the barren emptiness of the edge. We're exactly where we need to be, safe in the middle, cradled in the perfect spiral arm for a long, undisturbed sleep. Finally, we look outward from our safe harbour to the largest structures of motion in the universe, the Great Walls. We spoke of the cosmic web, but within that web are specific dense sheets of galaxies, like the Sloan Great Wall or the Boss Great Wall. Visualize a wall, not of brick or stone, but of light, a curtain of galaxies stretching for 1 billion light-years. It is a barrier of brilliance. These walls separate the vast voids. They are the continents of the universe. To see a great wall is to see the collective effort of gravity over billions of years, shepherding the galaxies into a lineup. It creates a sense of horizon. The universe is not just an endless scattering. It has geography. It has mountain ranges made of star cities. These walls stand as the ancient monuments of the cosmos, the largest things that exist, silent ramparts of light that define the shape of the known universe, holding the voids in place and giving structure to the infinite dark. From these colossal walls of light, the ancient ramparts that define the very shape of the cosmos, we draw our focus inward for the final, most profound revelation of all. We have travelled from the surface of the sun to the edge of the visible universe, but the 101st fact is not about a star out there. It is about the connection between the light and the eye that beholds it. Consider the journey of a single photon. It begins in the crushing heart of a star, fighting its way to the surface for 1 million years, then flies across the freezing void for centuries, dodging dust clouds and planets, travelling a lonely, silent path across the abyss. And finally, after all that time and distance, it ends its journey by striking the retina of your eye. In that moment, the star touches you. But more importantly, in that moment, the universe becomes aware of itself. This is the ultimate secret. You're not an observer separate from the cosmos. You are the cosmos awake. The atoms in your eyes were forged in the fires of long-dead suns. The energy in your brain that processes the beauty of the night sky is the same energy that powers the fusion of the stars. When you look up, it is not a human looking at a star. It is the universe looking in a mirror. Visualize this loop of connection. The star creates the light. The star creates the carbon and oxygen that make the body. The body creates the eye. The eye sees the light. It is a perfect circle. You are the way the stars know they exist. Without you, without the dreamer, the universe would be a dark, unseen theatre. You are the witness. You are the culmination of 14 billion years of cooling, expanding and evolving, all leading to this quiet moment where you can lie back, close your eyes, and hold the entire galaxy within your imagination. You're not small, you're vast. You contain the history of time, the heat of the supernovas, and the stillness of the voids within your own being. You're the sky, draped in skin, resting for a moment on a small blue world, dreaming of your origins, and so the journey concludes. The great tour of the heavens begins to fade, not into nothingness, but into a soft, comforting blur. The great walls of galaxies recede into the distance, becoming faint ribbons of mist. The spinning pulsars slow their rhythm, fading into a gentle, steady hum. The bright blue giants and the deep red garnets dim their lights, turning down the dimmer switch of the cosmos. The colours of the nebulas, the pinks, the teals, the golds, dissolve into a soothing velvet grey. You're drifting back now, floating down from the height of the galactic halo, sinking softly through the spiral arms, drifting past the quiet outer planets, past the rings of Saturn, past the watching moon. You're returning to the centre of your own personal universe. Feel the gravity of Earth welcoming you back, not as a weight, but as a warm, heavy blanket. Your body is sinking deeper into the mattress, heavy with relaxation, heavy with starlight. The show is over. The theatre of the night is darkening, but the peace remains. There is nothing left to see, nothing left to learn, nothing left to do. The stars will continue their silent, majestic dance without you, guarding the night while you drift away. The universe is safe. You are safe. The silence is wrapping around you like a cocoon. Your breathing is slow, deep, and rhythmic, matching the slow rotation of the galaxy. Everything is still, everything is quiet, everything is perfect. Let go of the images, let go of the names, let go of the light. Just drift, sink, rest. And now, 101 wonders are resting with you. Sleep now. Good night.